I?
Yeah, go for it. Okay.
Hide this in a pocket.
Yeah, I'll put that in there. Move that there. Hello, hello. Hello, hello, hello. Okay, fantastic. Thank you. Thank you. Yeah. Mm-hmm. Sorry? There will be live coding. Yeah. Oh. Andrea?
Do you mind if we wait like 5 minutes more?
Yeah, perfect. I saw the pictures.
We have the coffee break afterwards.
Yeah,
So
yeah.
we can just go.
Yeah, perfect. Fine.
Facciamo 9:20, facciamo 9:20.
Sì, ok, ok, ok. Yeah, some people are late. They're still waiting for the second bottle of water.
Thank you.
Good morning, everyone. Good morning, and welcome to the first keynote of the day. Couple of things first. There are still a few seats available in the front rows, so in case you want to see better, you can take those seats. Remember to write your question using Slido. Please do observe the code of conduct while doing so. And all the questions will be answered at the end. So now I want to introduce you my dear friend and former colleague, Nicolas Tollervey, who is going to talk about creative, compassionate code. Welcome, Nicolas.
Thank you. Okay, good morning. It's a huge privilege to speak here at PyCon Italia. The sense I get from having been here is that, well, it's been a lot of fun. So I just want to congratulate people who have made PyCon Italia possible. Fabio's just realized he's now on the screen. Everybody seems to be having a wonderful time, and just so you know, I was sent this message at 3:15 a.m. this morning. So bravo to everyone involved in organizing this conference in beautiful Bologna. So let's get to know each other. So I'm Nicolas. This is me in my natural habitat. I'm actually a classically trained musician. And much of my time I spend wondering to myself, I wonder how long it'll take before people figure out I'm just a tuba player with no formal computing training. I also have a background in academic philosophy, of all things, as well. So ethics, political philosophy, philosophy of mind, the ancient Greek philosopher Heraclitus, things like that, but especially philosophy of education. And after realizing that music was a really terrible career choice, there's only one tuba player in an orchestra, and there's only about 10 professional orchestras in the UK, so you do the maths. I did what most musicians do, and I became a teacher, a music teacher. And this is me. I'm aged 23, and this is my first day as a fully qualified teacher with my wonderful form. But nobody actually explained to me that there was a dress code at the school and I should be wearing a necktie. And when my own kids arrived, I left teaching to become a software engineer. I'm also still vaguely involved in the community, especially via the wonderful EuroPython conference, which is in Prague for the last time. So it's great company, a great city, and especially being Czechia, a great beer as well. And you're all invited, so please come to Prague. I hope to see you all there. So I want to learn a little bit about you folks as well. So hands up if you're Italian. Unsurprisingly, that's most of you. Okay, let's just broaden this to our neighbors. French. One solitary Frenchman. Bonjour. Bienvenue. Swiss. Hey. Austrian. Nope. Slovenian, I believe. Welcome, welcome. Okay, Europe, if you're from Europe or wider. Okay, I thought that might happen. Of course, if you're Italian, you're in Europe. I mean, you know, sets are so hard, aren't they? Okay, Africa. Hey, welcome. Asia, I mean in the broadest sense here. Welcome. America, both north and south. Welcome, 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 welcome. And Oceania, which is basically, well, you work it out. Okay. Okay, so, you know, we all had fun last night, especially Fabio by the looks of it. So everybody stand up. Just going to wake you up a little bit here. Now sit down if your coding experience is you're a total beginner, or you have little experience, or you're actually wondering, why on earth am I at a PyCon? So sit down now. So my wife just sat down, she's a cellist. Okay, if you have 2 years or less experience coding. Okay, well, welcome to the community. 5 years or less. Oh, right, okay. So there's about a third of the people sitting down now. 10 years or less. Well, that's got rid of most of you. Okay, 20 years. We're starting to get to the old-timers now. 40 years or less. Go talk to these people. They have a wealth of knowledge and experience. You could sit down now, please. You need to, yes. So here's what's coming. I'm going to tell you 3 framing stories about my life as a coder. And these will raise questions about our coding culture. And I'll conclude with an exploration of how paying attention to things is of fundamental importance to us as software engineers. And my aim is to give you a space to think and to pay attention to what we actually do as engineers. So without further ado, let's dive into the 3 coding stories. In case you hadn't noticed, I'm actually old. I would have been stood up at the very end as well. And I'm a child of the 1980s. And this is my first computer. It's a BBC Micro. And every school was given one by the UK government. My dad was a head teacher, and he brought his school's computer home at weekends, and that's how I learned to code. And I was probably 8 or 9 at the time. Now, computers in the 80s were very, very different to the computers today. And you had to use your imagination a lot when you were using them. And there were lots of books like this one, which is actually my first computer book. I got this out of the local library. And who wouldn't want to make a game that made you feel like a fighter pilot in a spacecraft or something like that, despite the fact that the games only looked like a bunch of ASCII characters on the screen? Okay, you had to use your imagination. And this is actually the first computer program I ever entered into a computer, a Starship Takeoff, where you have to escape the aliens, okay? And this series of books is famous in the UK. It was by a publishing house called Usborne, and because of their cultural significance, you can still download them online. They engaged kids like my 8-year-old self into the nuts and bolts of programming by framing the code in an engaging story, and there were cute robots, but they explained line by line with annotations what was going on. This was epic code, and I wanted to escape the aliens, so I spent 2 hours typing the damn thing in, and what we got was some basic code like this. And when you actually look at the source code, it's just a guessing game. Okay? You just have to guess a number, and it'll say too low or too high. But by typing in the code, correcting the mistakes and the syntax errors, and following the debugging guide at the back of the book, I learned how the code worked. And then, as an adventurous 8-year-old, I went off-piste a bit. I have very clear memories of my aunt and uncle and cousins staying with my family at the time, and I changed the code to something more like an 8 or 9-year-old kid would enjoy. And I invited my Uncle Colin, who was an engineer, to play the modified game. And I sat back to watch what happened. Now, being an engineer, my Uncle Colin thought there was some sort of physics simulation going on. Well, of course, there isn't. It's just a guessing game. And eventually, he ran into line 160. And he quickly left, muttering under his breath how the computer was broken. And I remember laughing like a maniac when I found myself alone because I had managed to somehow hoodwink an adult by making the computer do something cool. I felt empowered. I felt the creative juices flowing. And I was excited to learn what else I could do with this computer. So a quick show of hands here. How many of you remember an equivalent younger version of yourself having that sort of a feeling when you've used computers? Put your hands up. Okay, unsurprisingly, that's most of you. Okay, this is perhaps why we're all coders in the room. So, with the encouragement of my teenage cousin, Michael, I started to create my own programs. Simple silliness that would appeal to the 9-year-old boy growing up in the mid-1980s. Now, this is an emulator for a BBC Micro. And let's see if I can capture the cursor. And I can do things like CLS, clear screen. Okay, so the sorts of programs I was writing were things like this classic, you are an idiot. Okay, line 20. What goes on line 20? Go to 10, yeah, that's it. And if I run it, woo, you're an idiot. But here's the thing. I can press the escape key. And it stops. And I didn't want that to happen. And I realized that if I actually read the manual or looked at the books or asked my cousin Michael, who was a teenager and clearly was enjoying that he had a little cousin who was doing all this stupid stuff, I could type in things like, so if I list the source code, so I'm going to put on line 5, star FX 203, which is a special magic incantation that stops the escape key from working. So if I run it again and I keep pressing the escape key, it's just going to keep going and going and going and going. Now, I need to press break, okay? So that's like a hard reset of the computer. But with the BBC Micro, there was a way of being able to rebind the break key as well. So you could create code that would just run ad infinitum, and the only thing you could do is pull the wire out of the back and then put it back in, literally cut the electricity. So, I soon discovered new avenues of boyhood fun and mischief. When dragged off shopping by my parents, I'd wander off on my own to find the computer stands at retailers. And this photo with the sort of Lady Diana lookalike is typical of what these things looked like at the time. Now, being a kid, I was mostly ignored. Remember, I was 8 or 9 at the time. As I typed code, the sort of code I just showed you, into the demonstration machines. And I'd walk away after typing run and surreptitiously observe the next person to encounter the demonstration machines, all of them telling them they were an idiot ad infinitum and they couldn't make it do anything else but tell them it was an idiot. But in the end, I learned an important lesson. After leaving my unstoppable and mildly insulting code running on a BBC Micro at a shop, I was horrified to see that one of the retail assistants was being reprimanded by their manager. And my joke wasn't funny anymore, and I realized that my code had consequences for others. And that's a lesson that stays with me to this day. So what did I learn? Well, my first steps in computing are a mixture of empowerment, exploration, and ethical lessons. I was very lucky to have access to the BBC's computing literacy project and to have supportive teachers and a rather mischievous cousin to encourage me to play. And without these foundational experiences, I wouldn't be a software engineer. Because asking what sort of education we want is the same as asking what sort of community we want to become. For education is the process through which we interact with our future colleagues, collaborators, and friends. This is why education is so important. Thinking about education is a form of paying attention to the future. It's how we change things. It's also how we embody what and how engineers should pay attention to in their work, because people look at us and they learn from us. And in this way, younger folks or beginners grow into becoming engineers. And this is what I'm going to explore in the next story, which is a story of Python in education. I want to pay attention to the sorts of Python tools beginners may encounter if they want to become coders. Now, since beginners want to do the stuff we do, we should pay attention to the tools that we use as we think about how beginners engage with them. What's this? There's a lot of embarrassed people going, it's Vim, I recognize that. At least it's not Emacs. Vim is, the learning curve is like that, to use Vim as an editor. Okay, it's the editor I use, and the only reason I use it is because in the mid-90s, when I was at university, that's all we had on the university computers, okay, and it's muscle memory. Vim sort of looks like this big red button. You're not quite sure what you've got to do with it, but it looks rather dangerous, okay, and it's very, very minimalist. What's this? VS Code. Okay. There's a lot going on there, isn't there? It's sort of information overload, and it's a little bit like looking at the space shuttle, flight deck. Okay. There's lots of buttons and knobs and information, and what's going on? Okay. So I want to introduce you to Mu. Now, Mu is a beginner-friendly Python editor, and I helped start it with an idle and dangerous Sunday afternoon thought: how hard can it be to write a code editor? But it's sort of taken on a life of its own, and it's had millions of downloads, and it's used in books and learning resources and videos all over the world, and it's used in all sorts of places as well. I've had emails from schools in rural China and professors in Ivy League universities in the US, and they use Mu, okay? But it's a very simple code editor as well, okay? There's not a lot going on. But what is going on should be blindingly obvious. But who needs Mu? Okay. Well, this is a BBC microbit, and in 2016, 1 million of these devices were manufactured so that every 11-year-old in the UK got one. Each device was capable of running MicroPython. Now, the PSF were a partner in this project, and I coordinated with Damien George, the creator of MicroPython, to build the APIs and the tooling around Python on the microbit. Now, happily, we were also helped by a number of wonderful volunteers in the UK Python community as well. It's a real team effort. But we found that the tools that the BBC wanted us to build were not what teachers or students wanted, nor found easy to use. And so Mu was born. How hard can it be, is what we stupidly asked ourselves. So what did we do to create Mu? Well, here's a picture of me pointing at a picture of a man pointing at a picture, okay? The levels of meta going on here are really interesting. So that's the most teachery thing you're likely to see all day, okay? And we obsessed about teacher and student feedback. And here's a good example of this. After showing an early version of Mu to a group of teachers in a workshop, they explained that they always found it difficult to change the font size in editors, because they were hidden away in so many submenus, so learners at the back of the class could see what they were actually typing in. Okay? Now, honestly, it took me about 5 minutes to put a zoom in and a zoom out button onto the Mu user interface. Okay? Yet for the teachers, this was a killer feature, since it involved a fundamental pain point for them. And the only way we discovered that is actually by going and talking to them. Okay? We also wanted to be inclusive, and so we spent a lot of time learning about accessibility as well. We worked extensively with a blind developer at the BBC who made sure that the screen readers that he used and other assistive technologies worked correctly with Mu. And sadly, I have to report that that was a right pain in the bum to get right, because this is complicated technology. And we also ran lots of workshops and observed beginners, not just kids, trying to get to grips with learning to code. Yes, so this is a long, slow process. I just want to say, the kids that you're about to see, the two little boys are my sons, who are now kind of like, they're leaving home now. Okay, this is from a few years ago, and they're with their friend Amelia, and they're trying to debug some code. So you'll see their story as I explain what's going on. Okay, this is a long and slow process, and at times, we've all been there, a very frustrating journey. Okay, but we were able to see how learners and teachers encountered, explored, and overcame the problems that they found. So Big Brother Sam is pointing out a syntax error, I think, there. By taking these steps, learners practiced what it is to be a Python coder. Ooh, is it going to run? With an editor whose sole focus was to help them flourish. It works. And this was a humbling experience. Beginners, by virtue of being beginners, don't have the know-how nor skill to be able to describe the rather technical problems that they might encounter, nor are they very good at producing reproducible bug reports either. Often it just didn't work. Yeah, well, what did you do? I can't remember. Okay. So my co-maintainers and I spent a lot of time trying to figure out how it felt to be a beginner. Now, if you're an old-time coder like me, that's a rather difficult thing to do, because you're sort of blind to all the assumptions that you feel you have. This is very, very hard. We also paid close attention to cultural context. Allez, France. I spent time with French computing teachers and Welsh language learners. And they told me that it's not the programming language itself, but the language of the tools that is important to help them engage with learning. It doesn't matter that Python is an English programming language, but what really helped them out was the fact that their code editor spoke French to them. Also, the French can never agree on their translations. There have been more pull requests about the French translation of Mu than any other aspect of Mu. So, vive la France. So by paying attention to Mu in a certain way, we're demonstrating a certain sort of coding culture. And Mu is also the means of passing on that culture as well. That culture is open, collaborative, and supportive, and therefore so is Mu. And I want to just publicly acknowledge and celebrate my co-maintainers. This is us at EuroPython a couple of years ago. And this is what open source development is supposed to be. To paraphrase my buddy Brett Cannon, we came for the project, but we stayed for the community, for the friendship, for the fellowship, for the, it doesn't work. Are you going to fix it, Tiago? Well, I'm not. It's been an absolute privilege to collaborate with my friends Tiago, Vasco, Carlos, and Tim. But sadly, it's not always like this. This was my Mu-related inbox a few years ago. Yeah, whoops. I wasn't the only Mu maintainer to get such distressing emails. Now, folks feel strongly about editors, and we get that. And I woke up to this torrent of abuse on a Saturday morning, and I was supposed to be taking my son to a wonderful football game, and actually it ruined my weekend. But this is just the tip of the iceberg when it comes to my experience of problematic behavior in the open source community, and especially in the UK Python community. The most unhealthy thing that we can do is double down on the Python community awesome, we're all really great, it's awesome and welcoming, because it's not at times. That's not honest. And we need to honestly acknowledge that there is actually a lot of unpleasant and difficult stuff going on in all of our communities all over the world. And only by speaking honestly, gently, and with compassion can we engage with, address, and move on from the difficult stuff, rather than sticking our fingers in our ears or putting our heads in the sand and going, la, 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 not listening. This is important stuff. So what did I learn? Well, compassionate engagement with users is humbling. Keep it simple, stupid, that's an obvious one. But also, the community is amazing and terrible at the same time, a sort of a community paradox. So we've explored how we may pay attention to the next generation of coders, colleagues, and collaborators. But what of the future of the technology that we use? Where might Python be going in the not-too-distant future? And that's the subject of my next story. It's my privilege to work at Anaconda as a principal engineer on the open source PyScript team. How many of you have heard of or know about PyScript? Just put your hands up. Good. That's most of you. I'm pleased to see that Fabio put his hand up. But what is PyScript? Well, PyScript is an open source platform for Python in the browser. And importantly, it's sponsored by Anaconda. It's an independent open source software it's an independent project, but Anaconda pay the salaries of the core maintainers, most of whom are in the room today. So if Python in the web had a baby, it would be PyScript. And so how does it work? Well, if the white rectangle is the browser, at the very bottom of the stack is WebAssembly. And WebAssembly is a virtual machine to which you can compile C code to its instruction set. Okay? And so since CPython, hint, the clue is in the name, and MicroPython are both written in C, we can compile Python to WebAssembly and therefore get them to run in the browser. And we sit on the shoulders of giants in this respect. The Pyodide project have spent several years and a lot of hard work on making the CPython interpreter work with WASM. MicroPython, of course, I have an already existing relationship with Damien. MicroPython is written in ANSI-C, and it works really remarkably well in the browser as well. And so PyScript orchestrates the interpreters and brings a higher-level browser-based API to you, so it makes it easy for you to interact with the browser. And so sitting on top of PyScript, your code does stuff in the browser, or we've even got people creating frameworks now for PyScript so folks can write Python applications in the browser. And we'll come on to that in a moment. So the frameworks provide scaffolding for certain sorts of projects that you might want to write. So now the Python you know and love works anywhere the browser works. This video shows the PyScript bunny logo, because we always used to go PyScript like that, and so bunny ears. And this is the PyScript bunny logo as designed by a friend of mine, running via PyScript using the turtle module. So you've heard of Leonardo and Michelangelo, and now you have Antonio Cuni as a great Italian artist. Antonio, stand up, stand up. Woo! Now Antonio's masterpieces run everywhere PyScript works, which is everywhere there's a browser, which is pretty much everywhere. Most importantly, you can share your Python code now just with the click of a URL. Now just imagine how much friction we've removed by running Python in the browser. Desktops, laptops, mobiles, tablets, cars, fridges, point-of-sale machines, signage, you name it. The list goes on of all the places where a browser runs, and now Python does. And since, here we go, some live coding. Since my slides are in a browser, this is PyScript running in the browser. So let's see if I can do typing from PyScript.web import page. So this is one of the things that we bring to the ecosystem, is that we have a PyScript namespace that brings an awful lot of really helpful and simple and Pythonic tooling to you. There is what's called an FFI, a foreign function interface, that allows us to plug into the JavaScript stuff underneath, but that's idiomatic JavaScript, okay, and we want to give you something Pythonic. Okay, so what I'm going to do, page represents, guess what, the page. And so I want to find the slides on my page, so I'm going to do page.find. And all I use is a CSS selector, like that. Let's just check. I've got some results. Yep, OK. Slides.style background. I can't actually see what I'm typing here. Color, because I'm facing in that direction, and the code's behind me equals, I don't know, red. Ta-da! It works. Let's put that back. OK. So where's my pointer gone? Back here. So it's very easy to get stuff working in the browser with PyScript. But PyScript just isn't about getting Python, arguably the world's most popular programming language at the time, to run on the web, which is perhaps the most ubiquitous computing platform in history. From the get-go, our focus has been on empowerment so that everyone can benefit from Python and open source practices. And when Peter is the founder of Anaconda, when Peter announced PyScript at a keynote 3 years ago at PyCon US, he said that PyScript was for the 99%. And that's what, that emphasis on empowerment is what's behind Peter's claim that PyScript is for the 99% of the planet who may not be professional coders. They might be beginners learning Python, or they might be people who are using Python orthogonally to their real job. They are data scientists, or they are, real scientists. No, hang on, that came out wrong. Data scientists, they are geologists, let's say, and they need Python, or they're physicists, or something like that, okay? And Python, I've seen this having been a teacher. If your opening gambit is, okay, open your terminal, and everybody looks at you blankly and goes, what's a terminal? Then, okay, you're in trouble, okay? So putting it in the browser makes it easy, okay? So this sort of exercise should feel familiar to you, because it's a similar exercise to the one we encountered with the Mu project. And I just want to let you know that myself and Josh and Martin, a couple of colleagues at Anaconda, are working on an app framework for beginners, beginners in the broadest sense, not just children, this is adults as well. And this is called Invent because, well, it helps you invent stuff, okay? Invent with Python and share your work with the world through a browser. Also, and here's the caveat with Invent, if you're asking deeply technical questions about Invent, then you're probably not the target audience for Invent. Okay? And that's because, like Mu, it's a stepping stone technology onto more sophisticated ways of working. If you're asking deeply technical questions, go use something that's deeply technical, because that's where your level of experience is. Okay? So the Invent framework has had a very long gestation period. This is a wonderful group of learners that I worked with just prior to COVID times. So in 2019, I ran a bunch of coding workshops for a diverse group of people, lots of different ages, lots of different backgrounds, neurodiverse, et cetera, et cetera. And print hello world just didn't cut the mustard, okay? That's because for most of these people, their primary computing device is one of these black mirrors. Okay? And what you want to do is be able to go home and go, hey, Mum, look what I built. And print hello world is really quite boring if you're used to an Xbox or a PlayStation or a standard PC or something like that. So I wanted to try and build something that allowed them to get there rather than print hello world. And so I created, using Kivy, something that I called PyCon, which was inspired by HyperCard, which is an app framework from the 1980s. Okay? And my focus was to use a limited number of easy-to-understand core concepts that were simple to assemble, like Lego, that were extensible, but most importantly for me, easily teachable. Now, when I joined Anaconda, we renamed HyperCard to Invent because HyperCard has a sort of a legacy for those of us who are old. We remember it, and I didn't want that weight on the shoulders, on our shoulders as we were developing it. And of course, instead of Kivy, I'm using PyScript now as the underlying technology to deliver Invent apps. So what are the core concepts of an Invent application? Well, they're very simple. There are pages in your app, and each of those pages contain user interface components that are used in the app, so buttons, sliders, things like that. There's media associated with your app. These are things like, the assets that the app uses, like sounds, images, videos, that sort of thing. Python functions define the custom behavior of the app. This is where the business logic is. And the functions actually react to messages, and messages are sent via channels, and the channels carry messages to coordinate the behavior of the application. We also have a data store that keeps state, and it is a very simple key value store. Now, the data store also publishes on the channels, so it will say, hey, the value at this key has been set to this new value. Okay, so you can subscribe to changes in the data store. Okay. And then we also have some built-in tools that do asynchronous work and then store the results, if required, in the data store. That's it. 6 core concepts that are very easy to teach. Most importantly, they're very easy to learn because I can imagine a way of teaching those without going anywhere near a computer. We can use unplugged activities to get the mental models of what these might be using goofy classroom exercises rather than code. So when beginners come to the code, they have a model, such as channels is like, I don't know, a walkie-talkie. You subscribe to a particular channel, and anyone broadcasting on that channel, everybody else can hear it, okay? So what does an Invent app look like? This is an Italian traffic simulator. We designed an app. I'm just looking at Fabio because this is his idea, so you can blame him. We designed it so you could express yourself in as few lines of code as possible. Why? Because teachers told us if we can get beginners to figure out how to write 10 lines of code independently in a single lesson, then we're winning, okay? 10 lines, just 10 lines in an hour's lesson, right? They're not churning out code like we might do. It's very difficult. So the least amount of code, less code is better for them, okay? So we designed the API such that code written with that API, when read out, also tells you what it's doing. I learned that when doing the microbit work as well, okay? When I'm reading my code, it's very important that it sort of tells me what's going on, okay? And it turns out that API design is an art with a certain aesthetic way of paying attention. Technical considerations are, of course, important, but they're only part of the story. So how does it look? Well, I import a bunch of stuff from the Invent framework. I initialize the application, and essentially all I need to do is initialize a data store value, the number of honks. You can see where this is going. And then we have a function that handles a message. And all that it does is with make honk, it increments the number of honks that you have made in your Italian traffic simulator, and it plays a honking sound for you as well. It uses a task, sound.play, to play some media as well, okay? Now, the reason we don't use paths with media is because beginners it's hard enough for me to remember where the paths are, so we let the Invent framework do all of that for you as well. So invent.media.sounds.honk.mp3 gets you the right thing automatically. And then we subscribe the make honk function to the channel honk when the subject is press a button or touch an image, okay? Because every message has a subject. And then we start to assemble the app. So the app has a name, Honk Italia, and it has pages. It has just a single page, and that page has children, which is, of course, the UI elements. And what are they? Well, there's an image that displays some media, and it publishes to the channel honk, okay? And there's some sort of like alignment and display type information there. We also have a button called honk that also publishes to the honk channel. And then we have a label at the bottom whose text comes from the data store against the key number of honks. Look, I'm almost reading the code out here, okay? And then what do? We go, okay? So what's it like? Well, you tell me. Hold up your phone, scan the QR code, and let's see how much honking we can make. Go! It all looks like a rock concert at the moment. You've all got your phones up in the air. Oh, what's going on here? That's because I changed the CSS. That was today's deliberate mistake. So let me just... Yeah, hang on, let me just try this. There we go. Woo-hoo. Oh, there we go. I hope the conference Wi-Fi hasn't just crashed. Okay, I can hear beeping. Hey, here we go. Oh, yeah, okay, we've managed to melt the hotel Wi-Fi. There we go. I must say that the right-hand side of the room is the angrier-sounding bunch. There's more Wi-Fi on that side of the room, clearly. Okay. Let's stop the honking. Let's stop the honking. Otherwise, we'll be here all morning. I knew this was a bad idea, Fabio. Okay, so what did I learn? Well, opportunity follows imagination. All that infernal honking. Imagining that we can bring Python and the web together provides us with a huge opportunity to create wonderful things. Please stop. Oh man, they'll never invite me back. Aesthetic attention prompts expression. So focusing on a simple, expressive, and small API fosters a sort of creative playfulness. And aligned vision attracts allies. Since we're focused on imagination and simplicity, we're attracting folks for whom this is very important. Teachers, beginners, folks for whom coding is not their primary job. We found allies from whom we can learn as we build PyScript. Now, I've already mentioned the involvement of my dear friend Antonio. Antonio doesn't just create great visual art. He's also an artist with code, too, and we're very blessed to have such a titan of coding in our midst helping us with PyScript. You should also know that PyScript is mostly Italian. My dear friend Fabio, who helped found PyCon Italia, looking very sexy here, many, many years ago, is also a former chair of EuroPython and now principal architect at Anaconda. And he's also the creator of PyScript, so you can blame him for all of this. Without Fabio, none of this would be possible. None of this and none of that, none of PyScript would be possible. So I would say go buy him a beer, but we also the photograph at the beginning, so go buy him a coffee is, I think, probably a more appropriate thing. And then, thank you. Where's that video gone? There was a video here. There we go. So, a long time ago, in a galaxy far, far away, a team of Pythonistas were learning the ways of the web browser by typing in thousands of lines of TypeScript into a 500K package called PyScript. There was huge potential, and folks looked on in wonder, but it was a bit heavy and unwieldy. And then Web Yoda arrived, a powerful wielder of the ways of the web browser. And he took the PyScript, and lifted up the code to make it as light as a feather and easy to move anywhere. Look at him, there he goes. From being 500 kilobytes and several megabytes for Pyodide, Web Yoda shrank the code base to idiomatic JavaScript of about only 30 kilobytes. 30 kilobytes. And with the inclusion of MicroPython weighing in at only 170 kilobytes, we now get Python in the browser for around 200 kilobytes. That's smaller than most hero images on a website. Although you can still use CPython with Pyodide and all the other sorts of things, the important thing is that you now have choices depending on what you want to achieve. Now, this is my friend Andrea, and he's a virtuoso JavaScript coder. And this is his very first PyCon. He is, of course, Web Yoda. So please make him feel welcome and buy him lots of beer. But not too much, because we do actually want him to write great code as well. So what did we learn? Famous quote from Alan Kay: perspective is worth 80 IQ points. Andrea's browser perspective, combined with strong Python perspectives from the rest of the team, gave us a small, fast, and powerful PyScript that we have today. So what do these stories tell us about coding? Well, paying attention is important. Such stories are fun, fulfilling, and show code as a way to flourish. Much of what makes such code the way it is depends on how we pay attention to what we're doing. Yet we all know that the world is full of code and computing of questionable quality and dodgy ethics that diminishes rather than enlarges our world. Let's reflect upon what happens as we engage, disengage, or even misengage with the world of Python code, through Python code, for there's a lot of danger. We might be finding problems that don't exist, creating thoughtless solutions, writing complicated code, measuring success in dubious ways, and following shallow best practices. So let's unpack those a little bit. Sadly, software engineers are often guilty of pathologizing the world. By that I mean engineers often see the world as a series of problems that require solutions. Now, I'm going to bring my philosophy background in here. I'm more with Søren Kierkegaard, the Danish philosopher. Life is not a problem to solve, but a reality to experience. For example, I'm in Italia. We like drinking coffee with friends, right? It's a mocha pot. I have a mocha pot, and I've had one for years. It's part of the ceremony of my morning routine, actually. There's something rather wonderful in making a coffee with a mocha. The simplicity, the smell, the great tasting coffee. But I guess it's not that great if you're in a hurry, though. But I would ask, why hurry making a coffee and drinking a coffee? Yet someone somewhere thought it a problem. And so they created instant coffee. So instant coffee isn't so much a thoughtless solution as a tasteless one. It feels to me like the annoying AI doors from Hitchhiker's Guide to the Galaxy that swoosh with the satisfaction of a job well done. The focus is misdirected from what's important, i.e. making great coffee or opening a door, to something ludicrous or slightly insane, like very fast coffee or overly polite ambient technology. Has anyone ever had a nice cup of instant coffee? I don't see any hands in the room. I guess it has one advantage. It's convenient. However, it has multiple disadvantages, that it tastes like dishwater being perhaps the most important one. But never fear, tech will save us. Yes, we can have great tasting coffee through the convenience of the touch of a button on a machine with all the beauty of a collection of spare parts for a Dalek. But what about the ceremony of making coffee? This is a seven-minute video of a model plugging things into other things and washing them and pressing buttons. And it kind of reminds me of setting up a misbehaving laser printer. It's about as much fun as writing YAML for a Kubernetes cluster, let's face it. This is definitely the useless technology from Hitchhiker's Guide to the Galaxy. Look at it. But there's more. This problem seems to be following me around. I noticed this device stuck to the wall of a bathroom cubicle I was using at London Stansted Airport whilst getting my flight here. Can someone tell me how you actually flush the toilet? And what happens if the fuse blows? And I don't know about you, but it's definitely giving off HAL 9000 vibes, right? Does it contain a camera in a toilet? Are you kidding me? Also, here's the fundamental flaw. Depending on which way you're facing whilst, doing your business, the reflective mirror-like sheen is very off-putting, and men will appreciate what I'm saying here. So I've mentioned Hitchhiker's Guide a few times. Douglas Adams, a technology enthusiast, understood and lampooned the tasteless design and use of computing. Now, I'm going to read you a quote from Douglas Adams. It's about the Sirius Cybernetics Corporation, who make all sorts of convenient technical solutions in the Hitchhiker's universe. So here's the quote. "It is very easy to be blinded by the essential uselessness of their products, by the sense of achievement you get from actually getting them to work at all. In other words, and this is the rock-solid principle on which the whole of the corporation's galaxy-wide success is founded, their fundamental design flaws are completely hidden by their superficial design flaws." Bingo. The utter uselessness of the technology distracts our attention from the mistake of ever having created such a thing in the first place. Nobody asked if it was a good idea to create a technical solution to the problem of making coffee. There likely isn't a problem. Rather, folks feel so relieved that the damn machine actually works and makes them a coffee in the morning that they forget that they probably don't need the machine in the first place. Now, the same overcomplication and blindness to superficial problems at the expense of fundamental problems also happens when we write code. So consider the classic joke about how to write Hello World. It puts into focus the way we pay attention to our work, how the way we pay attention to our work has influence over the quality of the work that we produce. As I show you these fragments of code, ask yourself, which coder am I? So you ask somebody to write a Hello World program, and a beginner would print Hello World. But a junior coder, they're getting used to Python, and they understand abstraction, and they start to sort of put things into functions and what have you, and so they create a hello function. And it might have like default args and stuff like that. And so you get code that looks like this. And then after a few years, you've learned all about object orientation and how flexible the Python programming language is and how you can introspect and stuff like that. And you're having really lots of fun enjoying using the language, but perhaps you don't have the wisdom to know when to apply those features. As I show you these fragments of code, and then you're an experienced coder, so you go back to Hello World. But actually, the best coders know, of course, you ain't going to need it, so they're not going to write the code in the first place, okay? Code that isn't written doesn't need maintaining, can't have bugs, and you don't need to test it. Given such engineering of dubious quality, we sometimes try to spin what we're up to in a positive light. We find ways to distract attention away from anything actually helpful, useful, or meaningful. We'd rather focus on something meaningless, but which, to a non-coder, looks like a significant measure of success. I want to draw your attention to a slide from a recent presentation about UV that I came across. Clearly, GitHub stars are now an important unit of measurement when it comes to success metrics. But what does this actually show? Actually, it means this project has great PR and a DevRel team. So well done, that team, and best of luck to UV, who are doing important work in our community. But perhaps we can all agree there are more important or helpful things to which we should be paying attention when it comes to coding. But what are these more important things to which we should be paying attention? How do we discover these things? And so we come at last to best practices that promise to solve all our problems. For example, right now, the use of AI is being promoted as a best practice in coding. But let's just remember that AI is simply just an acronym for PR. AI was bound to make an appearance in this talk at some point, and you can't help but be amazed by some of the results it produces. What I find interesting is how we pay attention to the outputs from AI. That it looks convincing doesn't necessarily mean that it is correct in any way. I'm also delightfully amazed at the way in which AI misdirects its attention, often with comic or unfortunate side effects. Researchers from Tufts shows that the quality of the questions used to prompt LLMs has a direct influence on the quality of the responses to such questions. Students who already know a little bit about coding will ask sensible questions and get sensible answers. Those who are inexperienced will ask crazy questions and get silly answers. Perhaps taking advice from an AI is not best practice after all. But what I really want to know is, where does such best practice come from? So, this is not Web Yoda, by the way. Beware people who offer themselves as gurus, who promote a system or offer pithy best practices. I've got 5 minutes. Paying attention to them can often be detrimental, simply because you cede responsibility for thinking for yourself. Perhaps this is also true when paying attention to AI. The computer says so in such a convincing manner, so it must be right. Here's the thing about such best practices. They're often really stupid and rely on the inherent intelligence and humanity of the participants to ensure that they're actually meaningful. Just look at the poor reputation of agile methodology. Its rules, processes, and best practices are enforced at the expense of, actual intelligence, insight, or compassionate ways of working. Happily, such tropes and best practices are ripe for satire. For poking fun is a great way to make a pertinent point. Perhaps the most famous example of this is Doug Zonger's chicken. In the early 2000s, Doug wrote an academic paper that followed all the guidelines, conventions, and best practices of a computer science report. But it only contains one word: chicken. Of course, we coders are far beyond being sent up for our own coding practices at a conference, right? I mean, it's not like every presentation at a PyCon follows a well-worn recipe, right? Chicken. Chicken, 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 chicken. Chicken, virtual env chicken, 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 source chicken, activate, chicken, chicken, pip install the chicken. Chicken. Chicken, 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 chicken. Chicken, 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 chicken. Chicken, 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 chicken. Thank you. Chicken, 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 GitHub chicken. Chicken, 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 source code chicken. Chicken, 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 egg, chicken. Chicken, 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 chicken. Chicken, function chicken, chicken. Chicken, 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 assert chicken, 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 chicken. Chicken, if chicken, chicken, try chicken, accept chicken, chicken. Chicken, chicken. Pip install chicken. Package chicken. Chicken, 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 read the chicken, docs chicken, 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 community chicken. Chicken, 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 chicken. Chicken? Chicken, 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 poulet. Chicken, 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 chicken. Pool, 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 poulet, poulet, poulet. Chicken, 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 chicken. Chicken, chicken. Pool request. Chicken, 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 chicken. No more chicken. Thank you. So, in closing, computers are not just machines for rapidly evaluating logical instructions. They are a medium through which we share and express our values, cultures, social world, and forms of life. They are only valuable because we are able to create and express things of significance through computers. Furthermore, the way we express things with computers, and that we actually choose this form of expression, is also of cultural significance. Like other forms of creative endeavor, computers reflect those who make, inhabit, and collaborate in such a medium. As we have seen, our world is polluted by complicated and unpleasant computerized gizmos, intelligent yet crushingly stupid conversational agents, programmable coffee makers, automatic toilet flushers, most of which are banal or frustrating to use. Such a shallow, invasive, and unfulfilling world of computing reflects our failure to think creatively while we focus on automating things in the most trivial, complicated, or inconvenient manner. Yet highlighting such a problematic state of affairs is helpful, for then we can compensate and rebalance. It's not that technology is intrinsically bad. I'm a software engineer. I enjoy technology. Rather, the way we pay attention to it is often thoughtless, shallow, and ill-judged. We often lose the sense of fun, flourishing, and fulfillment we encountered in the opening 3 stories. How we pay attention to the world reveals the world to us in a certain sort of way. Such creative attention is a potent and fluid process of encountering, understanding, and expressing. We discern the universe and also change the universe through our discerning and reacting to it. We pay attention in this creative manner because it gives us an enlarged, affirmative, and stimulating way to participate in and transform the universe. Put bluntly, it brings meaning to our lives. Douglas Adams very much understood the point I'm trying to make with the arbitrarily correct answer of 42. But the joke is on the pan-dimensional mice. We are in danger of becoming the pan-dimensional mice who are looking for a right answer rather than engaging in a creative process of flow and change. Pantare, as Heraclitus would say 2,500 years ago. Perhaps the most important thing we can pay attention to is ourselves. As this secret reveals, this is a tricky thing to do. Student, oh guru, what is the secret of success? Good judgment. How do you get good judgment? Experience. How do you get experience? Bad judgment. So what we pay attention is important. How we pay attention is equally consequential, but often unconscious. Considering why we pay attention is perhaps most significant. An engaging, poignant, and sadly neglected opportunity for self-examination. If we don't attempt compassionate self-examination, nor engage with each other with a sense of respect and humanity, we end up like tech bros. These are folks for whom computing is merely a shallow performance in extracting money through human-computer interactions. There is no artistry, humanity, nor morality in what they do. A rather wasted effort, in my not-so-humble opinion. A herd of tech bros circle together, bleating about the Pythonic weather. Don't be the sheep cut off from the mass, unable to pass, as someone with something interesting to say. Their mental masturbation ejaculates ever-fruitless discourse. Repackaged reportage from Hacker News, performative patronizing technical reviews, name-dropping semi-famous nerds, and infinite garbage of computery words, detached and empty with no spark of life, the real world ignored to cut off its strife. So clever they lack the intelligence to know we are vital and luminous souls who grow through connections and feelings and deep self-revealings, but their work fills the world with VC-funded dealings, squeezing huge profits through inhumane code. We're exploitable data points with privacy to erode. What do we call such a desperate crew? A wank of tech bros, that'll do. So my challenge to you is to rise above the merely technical view of computers. I hope you imagine, create, and participate in a meaningful, authentic, and engaging culture expressed with and through computers. One in which Python becomes a medium for informative, liberating, and expressive activities that enlarge ourselves, our world, and our place in it. Thank you. Rant over. Now, I think because of the audience participation, all that honking, listen to it. We've run out of time for questions, right?
Chicken. Sorry, I selected the wrong language. That's fine. Yes, we have questions.
Okay.
Okay. I don't know, one just disappeared. Yes, we have one. Do you think PyScript can be used somewhere else, or education is the main important field for this project?
It's not just education. I mean, clearly, because I have a background in education, that's kind of where my emphasis is. But we've all been beginner coders. In fact, we're all still beginner coders, because I'm still learning as well. Okay? So PyScript, I was talking to a gentleman this morning who was thinking about using PyScript to help with German ferries. There you go. It's just the convenience is that Python is in the browser. That's the secret magic sauce, really.
Okay, thank you. And there is another question about, so there is one aspect of coding that is always given for granted, the English language. Teaching kids in UK, the semantic of print function is much easier. I think there's a missing than for a Chinese or Italian kid. Have you tried to fix that?
So this goes back to the point about the tooling, the comments from my French colleagues and Welsh-speaking folks. It's not so much the Python is English, it's the tooling and the resources that's important. That needs to be localized. And I have a really cute video. It almost made it into this talk of a class of Chinese children using Mu in rural China. And they create Python code, and we could recognize it, but whenever they don't print hello world, it's print a whole bunch of Chinese characters that I have no idea. I'm assuming it's the equivalent of hello world in Chinese, okay? Ni hao, or something like that, okay? They understand how to make Python work, but the tooling and the context and the culture in which they're working is very much Chinese, so they feel empowered by it.
Thank you. I think there are also some greetings from Valerio. Maybe I will read them later.
From Valerio. Hi, Valerio.
Hi. And the next question is, does Invent work on CPython or other Python implementation, not PyScript?
It works with MicroPython and CPython, Pyodide. Pyodide So it won't work with CPython, regular CPython. It's designed to work in the browser, so you need to use PyDide or MicroPython. We use MicroPython because MicroPython starts up, assuming the Wi-Fi is working, of course. MicroPython starts up very, very, very quickly.
Okay, and then we have someone who really enjoyed the chicken part, but they're not sure they got the point. So if you can explain it.
Chicken, 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 chicken.
Yeah.
Chicken, 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 chicken. Polo, 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 polo. There we go.
Yeah, I think that was the point.
I know. Hey, I'm a philosopher. I'm always asking, what's the point? So
And one last question, I think. How not to be annoyed by critics, such those that you got about Mu?
Okay, that's a really interesting question. How not to be annoyed? I would say actually you should be annoyed, and you should welcome being annoyed. How you express that annoyance, though, is very important. If you turn that around and you become the, the troll, as it were, then you're not helping anybody. But I hope that you call people out. I hope that in calling them out and doing so in a respectful and compassionate way, you are showing them and demonstrating and embodying to them how they really should and ought to be behaving. Okay? So feel annoyed, but be careful how you express that annoyance.
And I personally have a final question.
Yeah.
When you were writing, when you were showing the source code of chicken, I could not understand if you defined first the egg or the chicken. Can you explain that?
The code is on GitHub. You can go and have a look yourself.
Okay, thank you.
Thank you.
I think that's it. Thank
Coffee.
you for listening.
Thank you. Oh. Thank you, Andrea.
Let's try to
Okay, so I think it's time to start. We have this morning Riccardo that will talk to us about OpenTelemetry and Python, of course. I leave him to present himself, and a lot of people already know him, but let's give a round of applause.
Thank you. Welcome, everyone. And welcome to a sunny Bologna and a freezing Tagliatelle room. So, everyone, I'm Riccardo Magliocchetti. I work in observability at Elastic, where I maintain our Elastic distribution of OpenTelemetry Python, and I'm also a maintainer for the OpenTelemetry Python project. In this talk, I want to show you how to add observability to a Python application using OpenTelemetry, and doing that without changes to your application code. This kind of instrumentation is also known as auto-instrumentation or zero-code instrumentation. So today we see, first we look at the OpenTelemetry operator. That is a Kubernetes operator to manage an OpenTelemetry collector instance and to inject also the Python auto-instrumentation into your Kubernetes pods. Then we'll take a look at the OpenTelemetry Python own auto-instrumentation solution based on the OpenTelemetry instrument wrapper. And after that, we'll take a brief look on how to add auto-instrumentation programmatically using just 2 lines of code. And finally, if you have time, and I hope so, we'll take a look at the GenAI work we are doing inside OpenTelemetry. So I'll start by giving to people that are new to this space, new to observability and OpenTelemetry, a brief introduction. Please note, this is not an observability or an OpenTelemetry tutorial, but just to give a bit of context. Waiting for the door to close. And thank you. And how many of you already know OpenTelemetry? Please raise your hands. Okay, most of the room, nice. First time that I got that big percentage. And how many of you are using OpenTelemetry in production? Okay, dozen hands up, so nice. So observability is the ability to understand the internal state of a system by looking at its outputs. This means being able to understand a software system by looking at the telemetry data it exports. And in other words, unless you have a crystal ball, you of course need data to understand how your system is behaving and what they are doing in production. So OpenTelemetry is an open source project, and it's an observability framework providing both specification and implementation in order to create and manage this telemetry data. It is a CNCF, but CNCF is Cloud Native Computing Foundation, incubating project. So it's the same foundation of Kubernetes and other projects. So the telemetry data that OpenTelemetry handles are called signals. The first signal is traces that are used to follow requests or calls into your application. Think of HTTP calls, database calls, RPC calls, and stuff like that, but also plain function doing some computing inside your application. An example of tracing may look like this. Like in this picture, we see we are tracing 3 different services, and you can see the different colors, hopefully. And so we are able to trace the dependencies between them. Being able to see tracing between services is what is called also distributed tracing. The second signal that OpenTelemetry supports are called metrics, and they're just used to capture some measurement at runtime. For example, memory usage, CPU usage, maybe the time spent serving requests and stuff like that. And with metrics, we can get a clue on what's going on the system. This is a silly example, just charting CPU usage of an host machine and Kubernetes pods. And then the first signal is logs that are just some structured or unstructured text with a timestamp. And you're probably like logs are the most used signal already, so probably you are already used to an interface like this. Usually like they got a first signal in order to debug things. Yeah, this is just like an example of like filtering the logs from the recommendation service that is one service written in Python running in the OpenTelemetry demo. I hope this is like nothing new to you. Last support the signal in OpenTelemetry is profiles that is used for collecting profiling data on the activity running on the operating system. Sorry. Mind that profile signal is not stable yet, but people are working on it actively. That was enough for the introduction. Let's look at the option we have to serve our Python application using OpenTelemetry. So the first option is the Kubernetes operator. The operator consists of a Kubernetes operator, again, that manages a couple of things. First, it manages an OpenTelemetry collector instance. The OpenTelemetry collector is an implementation on how to receive, process, and export telemetry data in various formats. Default formats is the OpenTelemetry one, that is OTLP, but it also supports Prometheus and Jaeger or Jaeger protocols. And the operator also manages like a system to inject the auto-instrumentation code for a bunch of supported languages into your pods. And of course, Python is supported. And for Python, this works like quite simply, just by copying the Python OpenTelemetry code, auto-instrumentation code, to a volume that is then mounted into the application pod. Then the operator is also setting some environment variables for configuring the thing in order for having like the OpenTelemetry Python agent to work. The managed collector instance, while being optional, is advised because it lets you simplify like a bunch of things by acting as a proxy between like your application and the observability platform that will receive your data. First, it simplifies the management of secrets, where like only the collector will know like the secrets in order to write to your observability platform. And then it's also like an handy place to do some processing. Like you can filter data, you can aggregate things, deleting attributes, adding attributes, renaming metrics, stuff like that. Like I left a link on the slide if you're interested in more information. So the architecture of these things will look something like this, where you have like your application there, but are writing, exporting data to the auto collector. And the auto collector, again, is receiving processing and then exporting again to your observability platform. In this last month, there have been like a few nice improvements regarding Python instrumentation. We made more environment variables set by default, so you don't need to set them anymore. And I don't think you don't need to set anything at the moment. And we also had the support for muzzle-based container images, like the one based on the Alpine distribution. Please note that this work not only improved like the life of people like using the OpenTelemetry collector, Kubernetes operator, sorry, but also the ecosystem, because like we started the work on making like binary wheels for the gRPC-IO library for ArcSys64 on Muzzle. And like it took a while, but in the end we got them. And this is a big deal because I don't know if you are using gRPC-IO, but it takes ages to compile in CI. Now, let's look at some YAML, because why not? And this is what is required to configure the operator inside Kubernetes. So this is a toy manifest, where the bulk of the spec is just the OpenTelemetry collector configuration. And literally, all this stuff from spec down is the collector configuration. So the interesting bits that are highlighted in light green or whatever you call this color. So the interesting bits are, first, we are setting like two receivers, one for gRPC, listening on port 4317, and the other one for the HTTP port buff interface, listening on 4318. And the HTTP one is the default used by Python out instrumentation in Kubernetes operator. The other interesting thing, and this is why, because this is a toy manifest, YAML, we are just exporting to the collector logs, so we are not seeing data anywhere. And here, you'll have to configure like an exporter with the data and the specific receiver in order to write data to observability platform. Yeah, this is like what is we call pipelines, but it's just like a description on how we want to receive, process, and export our stuff. Then you have to set up the instrumentation resource for your Python services. And again, the only interesting things here is that we are setting just a local endpoint on port 4318, that is the HTTP one I showed before. And this is just like configuration for the Python out instrumentation. We don't go into details about that. Then this is like the deployment manifest of your application, but may look something like this. The interesting part here is this metadata part, where we are just saying like we want to inject the Python out instrumentation, and we are called the instrumentation or the Python instrumentation, which you can choose whatever name you want. And also, this is just an example on how to configure to choose the out instrumentation for the Muzzle C library, because like unfortunately, the switch between the default glibc out instrumentation and the Muzzle one is not automatic, so you have to configure it in this manifest, in your application manifest. Now, the bad parts, of course, like in always piece of code, there are also the bad parts. Currently, there are only one OpenTelemetry operator Python out instrumentation image built per operator version. This means that this image is built for a single Python version and contains both the glibc and the Muzzle instrumentation builds. And this leads to two problems. The first one is that some Python packages, as you may already know, install like some binary code, so binary wheels. And the problem with wheels is that wheels are most often built only for a single Python version and a single C library. And so the problem is that, for example, Python already, the Python out instrumentation code already is using some binary wheels, and specifically gRPC that we talked before. And also, we use PSUtil in order to create system metrics. And so the problem with this is that sometimes it may not work out of the box. And the second problem is that still we are building like one image for a Python version. And so some packages we install may not work on older Python version, or maybe even newer Python version. But for example, recently we got regression because one user was building, was running a service with Python 3.8, which you should not because it's not supported anymore. But they were doing that, and we were building the operator image with Python 3.11, and so we were installing a urllib3 version 2 new. That was not working in 3.8. And so we had to like revert to another version. And so the solution to this is the dumbest one, that is like to just build an image for the operator on Python instrumentation that matches the environment you're running it. And so build it with just the C library you need and also the Python version you need. And so this is an updated manifest of the one we showed before, where you just specify a specific Docker image instead of the standard one. And so this was the Kubernetes operator. Second option, in order to use OpenTelemetry without touching our code, is using the OpenTelemetry instrument wrapper. This wrapper works by doing some Python tricks under the hood in order to set up and load the Python hotel agent before your own code. I'll show you an example. This is taken from the Elastic distribution of OpenTelemetry Python I maintain, but it's just a basic Docker file, so you probably recognize it. And it is like a Flask application. The interesting part, again, the first one is here we're running a tool called e.bootstrap, but is our own version of the upstream one, but it's called OpenTelemetry Bootstrap. They do the very same things, it's just like different configuration. And these tools like scans what you have installed in your environment, and then like you can choose like to list or even install the possible instrumentation we can provide. So like the idea is that you don't need to know what instrumentation we have. You run this tool, and the instrumentation that are available for the stuff you are using will be installed automatically. And then the other important bits, and I hope you can see it, is this command definition, where we prefix the Flask run command with just OpenTelemetry instrument, that is our wrapper. And this is enough in order to have an instrumentation for a Flask service out of the box. So also, well, this is not enough because you, of course, have to configure things. And so the other, I guess, the important bits are that you have to set, of course, the environment variable for at least the endpoint where you want to send data, and the headers, for example, authentication. So by the way, if you are sending data to a local collector instance, you don't need any of this because the default is to send to a specific port, and by default you don't have authentication. So this is just like if you want to test it and send data somewhere. So if you're interested in how the OpenTelemetry agent works under the hood, I suggest you to take a look at this other code I'm done. This is a link to the recording for the talk at FOSDEM this year. Thank you. And yeah, like I submitted both talks to this conference, and you choose this one, so your choice. And the third option is programmatic, what you call programmatic auto-instrumentation. Programmatic auto-instrumentation, by definition, requires changing your application code, but not very much, and it's just a couple of lines of code. For configuration, this also relies on environment variables. And by the way, this example should be put like before everything of your code, because otherwise we are not able to initialize everything, initialize and instrument everything. But again, this is like maybe useful maybe in CI stuff where probably you have maybe some random scripts, but also like I don't know what they are, but they told me that people are using this in Databricks jobs or something like that in CI, and they were like happy with the solution. So what to use? As every engineer would say, like it depends. If you're using Kubernetes, of course, the operator may be your first choice because you don't have to touch your application code, and the ops people may just like inject stuff without your developers know. And just remember, you may need to build your own custom instrumentation image. Otherwise, there's the OpenTelemetry instrument to wrap your application entry points. This is still without changing your application code, but maybe just your Docker files or how you start your services. Third option, when you can't use the other one, I will say, you have this thing we call programmatic auto-instrumentation, which requires like to add 2 lines of code to your application. and still relies on environment variables for configuration. So this was the OpenTelemetry instrumentation part. Now we have plenty of time to look at what we are doing in OpenTelemetry regarding GenAI. So another question, like how many of you need to observe GenAI application? Python GenAI application, yeah, of course. So just have a bunch of hands. So there are two kinds of GenAI work going on in OpenTelemetry right now. I mean, like in the OpenTelemetry project, not in the OpenTelemetry like world, where a lot of things are going on. The first one is writing semantic convention for GenAI application. That is, semantic convention are like the specification of the output of tracing and metrics for a GenAI library, like what events we need to log, and what metrics, again, I already said, and what metrics to send. The second one, work we are doing inside the OpenTelemetry regarding GenAI, it's writing instrumentation for client libraries. And as you may imagine, like one work like influence the other, because like you write specification, when you write an instrumentation, but also like when you write instrumentation for maybe a new library, you have to update the specs because like maybe like the spec was not like semantic convention was not generic enough, or maybe like new libraries create new use cases and stuff like that. And at the moment, the GenAI semantic convention define like span attributes for tracing chat completion API calls. Spans are just like a unit of work that are the unit that compose a trace. And also span attributes for tracing embeddings API calls. By the way, chat completion API calls are when you ask like, you send to an LLM, just give me something, like you write in natural language and you get a response. Embeddings API are when you send like a string and you get the same thing in embeddings. So it's like an array of integer or floats more than integers. And then we have span attributes for agents invocation calls. And these are calls where you ask an agent to provide something. So this is a screenshot, ugly one, by the way, but this one I had it near me. So this is like an example of what we are testing right now. This is from a chatbot app, and is using the OpenAI library to query. This is a Qwen model locally. And yeah, so this is like a Qwen model hosted on Olama locally, traced by the OpenAI instrumentation. So this GenAI semantic convention also define a bunch of events for these various messages used in GenAI chat sessions. Events sent for the various messages include the various roles. So you have events for system messages, user messages, and assistant messages. We have an event for the responses from these LLMs, and also for the responsive of tool calls. Tool calls, if you don't know, like when these LLMs are not able to do like everything by their own, and so you provide some external system that can, or function, or something more complicated to provide some help to these LLM models. And yeah, and then of course the LLM responses. Yeah, this is like a still example of a response stored as an event. This is like the same logs interface we've seen before. Again, nothing interesting, just like a bunch of JSON data. So we define a couple of metrics, the duration of the operation in seconds. That is like the time when the API call to the model took. And then the number of input and output tokens. Again, this is just simple graphs, not very useful because you have two different stuff that has different units. but again, token used and operation usage in cycles. So on the Python side, at the moment, we have an OPI instrumentation, but mostly complete, I say. And the important thing is that with the OpenAI, we trace libraries and not models. And so with the OpenAI instrumentation, you can call other models, like other providers, stuff like that. We have a pretty complete AWS Bedrock implementation. We trace 4 APIs because, of course, AWS APIs, the more, the merrier. We have the converse and the invoke model, streaming and non-streaming implementation. And the problem with invoke model APIs are that these are old and model specific, so we test this thing with just a bunch of models. But we can support more. We have a Vertex AI instrumentation for the Google service. We have also a pretty complete GenAI, again, from Google GenAI SDK library. And yeah, what's next? On the Python instrumentation side, the plan is, of course, to conclude the missing features of all this instrumentation code. But the elephant in the room is that there is an ongoing discussion and a donation proposal from the OpenTelemetry project to donate all their instrumentation. And so if the donation will be successful, there will be quite a bit more instrumentation available. But still a lot of work to do because we have to update this instrumentation to the upstream semantic convention. And on semantic convention side, the most interesting word is, of course, MCP semantic convention, because everyone is writing MCPs right now. MCP are a common interface for being able for LLMs to being able to call a standardized interface your services. And yeah, to conclude, since we run out of time, we have seen the free system we can use to instrument without OpenTelemetry your Python application, without and with touching just 2 lines of code. And we also seen we are working on GenAI use cases inside OpenTelemetry. Here on the slides, I left a couple of links. The most important one is that, of course, if you're interested in these things, we have a Slack channel on the CNCF Slack. And we are always looking for help, of course. And yeah, I upload my slides here. Also, I upload them this morning. And yeah, probably also will be available on the PyCon website, I guess. And yeah, that's it. If you have time. Yeah.
Thank you. So we have a few times. 3 minutes, I think, and some questions. So I'll start directly with the first one. Does OpenTelemetry instrumentation, SQLite, and OpenTelemetry instrumentation URLib get installed on Bootstrap install command automatically?
Yeah.
Okay, this is fast.
So yeah, if you run the OpenTelemetry Bootstrap or e.bootstrap, it will scan your virtual environment.
Sorry.
Hello, cameras. No,
okay.
the SQLite and URLib that are already on the standard library.
Yeah, yeah. The thing is that for some instrumentation that are available in a standard library, like SQLite, Async.io, or threading or stuff like that, they will be always installed because they'll always be available. Yeah.
Okay, go to the next one. Does the GenAI telemetry utilize the same OpenTelemetry infrastructure?
Yeah, of course, yeah.
Yeah, straightforward. What are the best supported dashboard / exporter to start using OpenTelemetry?
Well, as I said, I work for Elastic, so I have to say Elastic, of course.
Okay, the last one is, does the GenAI telemetry also work with Azure OpenAI?
yeah, I think like we have test runs, like maybe I wasn't clear before. Like we are instrumenting libraries, and so if you're using the OpenAI library, querying Azure OpenAI, it really works just fine. Yeah.
Okay, thank you again,
Thank
Riccardo.
you.
The slide. See you in the next talk. we'll have the talk from Chiara, and she'll present herself, I think.
Yeah.
And let's give her a round of applause.
Thank you. Well, I'm very happy to be here today, and I have to say I'm also a bit nervous since this is my first talk in English. So I hope it's not too rusty. If you don't understand what I'm saying, just please raise your hand and stop me. Well, before everything else, at this link you find the material of the speech, because if you need some support, you will find the slides and a draft of what I'm going to say. So if you need to follow that, you find everything here. And in the meanwhile, I want to tell you how I arrived here today. Nothing fancy, nothing emotional, just literally how I got here. And this morning, I biked to the station. And I'm one of those people who bikes to the station at least in every weather, with the motto, there is no good or bad weather, just good or bad equipment. But the equipment you need when there is bad weather, it's way more difficult to prepare than the one you need when it's sunny. And so I checked the weather. And I checked it today and in the previous day. And I went to ilmeteo.it, which is one of the most visited websites in Italy in general and about weather. And they provide this useful table. And you can see the weather for each time of the day. So I checked the weather for the most relevant times for me. And then I thought that I'm not the only person who needs to be prepared about the weather. And so I tried to stress the website with a keyboard navigation, a screen reader navigation, and when I navigate ilmeteo.it via screen reader, now you can see actually what he's going to say, but it took me the announcement of 27 elements before having a clue about the weather. And then you will see it maybe right now, just a moment, and you will see that. You have the time, the weather about each day, and then this table that was very useful for me is completely skipped. Absolutely. If you are using a screen reader, you don't have a clue about the weather in each time of the day. And, well, if you are a legally blind person, you can be a complete blind person, but you also can be a not so... you can still have some point of view, spot of your field of vision still usable, and you will use that. And to show you that, I choose those video that is a funny video about a couple, and one of these husband is blind, and the other one pranks him continually about his blindness, and in this case is trying to see how long does it take to this blind husband to realize they're wearing matching outfit. And the relationship is like that more or less always, and it's funny, but this is clear that he can still spot something, that he has a small part of vision still usable, even if it's really, really small. And so even legally blind people can see sometimes some part of your page, but also a screen reader can be used also from people that have other kinds of disability. Yes, blind people, but also low vision people, also people with a cognitive disability, with deafness. That seems strange. Actually, if you your first language is a sign language, you will probably don't be so fluent in a written language. And also, it's not important which kind of disability. It's important that a lot of people can actually see the screen while using a screen reader. And imagine that experience we saw that is not fair for a complete blind person, how disorienting can be for a person that still sees some spot of the screen. Then my journey continued, and I took a train. Well, actually, I took 2 trains, but I have a pass for one of them, so I just bought the other one ticket, and I bought a ticket online. And since in Italy the high-velocity trains are provided both from Italia and to Italo, I checked the 2 websites. But then I thought again, what if I had tremors due to degenerative illness like Parkinson? What if I had a bad tendinitis? And what if simply my trackpad were broken and I wasn't able to use my trackpad, my mouse, and so on? And so I thought that I would probably navigate the website with a keyboard. And this is what happened when you navigate Italo website with a keyboard. Something is happening. You maybe can't see that, but something, now you can see that something is actually happening, and you can see that here, something is changing. But you have no visual focus, no visible focus on which part of the page you are in. And at a certain point, I managed to enter the departure and arrival form, but it wasn't possible on a keyboard navigation to select actually the 2 stations. And so I wasn't able to complete my task. Then I tried to do that on the Italia website, and in this case, the focus indicator is visible, and I'm not very fast because I'm not usually keyboard user, so you will see that I'm really, really slow doing all the process, and we can also skip a little bit of that. But I managed to look for all the timetable in Trenitalia. So, if I were a keyboard user, from which website do you think I would have bought my ticket? From the only one that was allowing me to do that. The reason is simple. I chose these 2 examples, not because these are the only things I encounter in my journey today. I probably met a lot of other barriers I didn't even notice because I'm not a disabled user. But I choose this example because are examples of digital inaccessibility. And digital accessibility is my focus since I am a user designer. And in the latest year, I realized how important it is, if you want to speak about user experience, to speak also about accessibility. In particular, accessibility address the needs of people with disabilities, but also, if you don't think more in general to the characteristic of a person, and so the called inclusive design, which take in consideration also characteristics like age, digital competence, economic background, status, and so on. And I share these things in a daily newsletter on LinkedIn that is called an Accessibility Link a Day. Well, coming back to the inaccessibility example we saw before, whose fault is this? Or better, whose responsibility is to guarantee accessibility on a website? It's a developer's fault. I'm brave because I think that a lot of you are developers to say that here. Well, I will arrive to the answer, but step by step, and with a shift of perspective. And the shift is shift accessibility left. Shift is left in terms of time. Accessibility needs to arrive at the beginning of the whole process. If we think about accessibility from the first phases of our project, it's simple. Maybe at the beginning it can be so easy, but then it began to be something that the whole team can actually see, and they don't need to think about that more after our initial period. For instance, it's impossible for me now not seeing a bad color contrast. I don't need to check it. I see it because I tried it a lot of times, and now it's impossible not to see that, or not to get that links and buttons doesn't have speaking text on them. Is it difficult? Well, in some cases, accessibility can be difficult, but in the most of the cases, you can start small, and starting small, you can start from these kind of things that are not so difficult to fix or better to avoid. This is a graph that is come from a research that is made each year, analyzing 1 million of home pages worldwide. And the most common wicked failures they found out in this home page are quite simple things, like low contrast on text. I'm speaking about text, not the other kind of graphical elements from which could be a little bit tricky sometimes to find out a solution. Missing alt text, missing labels and a link, missing empty buttons, missing language of the page. So these things are not so difficult to fix. And you can start from them. Not being able to guarantee 100% accessible, or better, compliant website can be an excuse not to work on something. But you have to shift it left also from a team member's point of view, because accessibility is a teamwork, and each person in the team has to be sure to guarantee these. And we now will see a little checklist that it's absolutely not complete. There are a lot of other things that can be done about accessibility, but we can start from these and then progress in our journey, because accessibility is a journey, not a destination. So for team leaders, need to provide training. Legals have to make sure that we understand the law and that we turn regulation into concrete action. Researchers, people doing all the requirement parts, need to remember to interview people with disability, because if we don't have a disability or we don't have a particular disability, we can see some things. I surely encountered other barriers on my way to get here to Bologna, but I wasn't able to see them. So it's important also to involve people with disability in the process. And then people like content designer needs to write clear text, easy to understand, with no jargon or abbreviation. Sometimes it's very difficult for people coming from another field to understand abbreviation. Also for me this morning, I listened to the keynote that I loved, but sometimes some abbreviation weren't so clear for me. Then maybe I arrived to them because I'm not in a completely outside world, but they're not so clear. They have to understand that headings are present and that are in a proper order. The text alternatives are present for images, like alt text, but also for other media. And the text on the buttons and link is meaningful. If you never try to navigate via screen reader a page that has those links like more, see, go, and things like that, do it, please, because it's a very funny way to listen to that marvelous echo effect. So please do that. For people that develop information architecture, have to be sure that content is in a logical structure that is easy to understand, that speaks the language of the people using that product, and also that page titles are useful and understandable. For visual designers need to check that there is a sufficient color contrast on each element, that color is not only used as the only way to convey information, that buttons and active elements are big enough to be touched or clicked, that detectable states are active for those elements, that the text is easy to read with choosing the right font, selecting the right line height with no wall of text. People doing UX, they have to be sure that every components have a behavior that is easy to understand, that errors are prevented, or at least that they are easy to recover, that the flows are linear, and that there aren't time constraints to them. And they have also to think about the reading and the focus order of the elements, and do that in collaboration with developers. Development. I know that this list is not complete and not exhaustive, but I made an effort to do that. And first of all, that the code is correct using standard HTML. And adding ARIA, but only if it's necessary, not always, not everywhere. They have... Sorry? Accessible, I don't know actually. That's a good question. I can't remember that actually. It is accessible enrichment of something like that. I actually didn't check that because I thought that all the developers knew that, and it's my fault. You're right. Thank you. Screen reader and keyboard navigation is enabled. Adding maybe the skip links, checking if focus is visible, and things like that. Check if the page is resizable. And also, at the end, quality assurance. And user testers need to, well, set accessibility as a goal and include people with disability. So, who is the responsibility of this, of making something accessible? The whole team. And from the beginning. And why care about that? Well, the first thing is easy, because of the law. And we have European Accessibility Act coming in a few days. But then also because it's a good marketing strategy. Remember the case of my train ticket. And I want to add that at the beginning of this year, in January, Italia was in the same position as Italy. It was impossible for a keyboard user to buy a ticket in Italy, online at least. It should have gone to a train station and bought the ticket physically. Because it's for everyone, yes, for people with a permanent disability, visual, auditory, but also cognitive or neurological disability, for people with a temporary disability, like the bad tendinitis, but also recovering from an eye surgery, things like that. But also for situational disability. When we are in a situation that disables us, we can experience that in a lot of ways, like seeing a screen in bright sun, or trying to listen to something in a very noisy place, having a baby on your arm, and not only babies, because when babies grow, they give you things to hold. So you always have your arm full of stuff. And if all those reasons are not enough, do it for yourself, for your future self, so for future self-ness, because if we are lucky, we will get older, and we will hear less, see less, have less dexterity. We'll have to deal with technology we never used before. So if you don't want to do that for anything else, do that for yourself. Thank you. Thank you.
Okay. So I'm asking before the question on Slido that I already asked 10 minutes ago. Then okay, then I give you. Okay, the first one is: have you tried to navigate the PyCon website?
Yes, I tried it, and probably it wasn't 100% accessible because 100% accessible is a unicorn, so no, but there weren't particularly things that enable completely the navigation. Also, an important thing is to guarantee that the main flows are accessible. If there is just one little thing that isn't, yeah, it's a good thing to fix it, but it's not so important. So it was okay. Not perfect, okay.
Okay, thank you. So we'll say to people that build the website, I don't know where they are. Okay. Would you say accessible is like security and needs to be part of the project from the beginning, not bolted at the end?
Yeah, because just think about it. You did all the things you have to be doing for doing a website, all the things. I mean, a lot of clicks, all these. And then, at the end, you have to begin again. Also, you have to do an audit, to do the audit, check for all the priorities, and re-implement, redesign. So it's really heavier than thinking about accessibility from the beginning. You need some training at the beginning, but then it's easier to do all the things.
Thank you. What about your slides? Are they accessible?
Quite accessible. I'm not really sure because these things is actually something strange to do because I just separate all the phrases, so there are different things, but there is a title that is accessible, and unfortunately PowerPoint doesn't allow me to just let the screen reader reading the title, but not these things. But I don't like very much PowerPoint, but it's the most accessible way to do an accessible presentation. Strange, but true. And that's why my presentation is in PowerPoint.
Thank you. Do you think that AI can help access to inaccessible websites?
Well, this is another talk, first of all. It surely can help in some ways. Just think about trying to help you writing an alt text, but I'm thinking also about all the possibility to read the environment you are in through the AI. But you don't have to forget about the people you're doing things for. And you have to put at the center of everything the people. And sometimes AI is not so good at understanding the context, at least not now. And so it can be something useful, but for the moment it can't fix accessibility. You can't fix accessibility through AI. You can use it to help you fix accessibility.
Hi. First of all, Chiara, thank you for your presentation. I think it was insightful and valuable, no matter of your role. And I just wanted to ask you, do you think there will be any negative effects from the that we could see from the European Accessibility Act, like cookie policy, health, for example?
I hope so. I'm actually not feeling so confident about that, because when you see things from just a legal point of view, you try just to fix the things to be compliant, but I would love if something positive is coming from that. Let's say that something positive is happening because some websites are trying to guarantee more accessibility. Like say Italia website actually wasn't until this March that was wasn't accessible by a keyboard. And so I hope that something good is coming from that, but I fear that when there is no shift of perspective, and just not shift left, but in general, I'm not so sure that we will see really accessible things. Like say, in Italy we have the Legge Stanca, which is a law that was requested to public, sorry, I can't say the word in this moment, public administrations to make a website accessible. Well, they are more accessible than other websites, but are not completely accessible. And it's 20 years that this law is around. So hope so, not so sure.
What about accessibility for developers? We talk every time about final website, but not about impaired developer that have to share instrument, usually closed source or similar.
Yeah, this is a very interesting field. Sometimes is completely forget the part for, like say, developers, but also internal users. We make maybe the website accessible, but we don't think about making our internet accessible. So our colleagues that needs support to visit our internet don't have this kind of possibility. I believe that we are not so close to also that, but maybe step by step we will arrive also to do things. I mean, maybe in some fields it's easier, like say, like things like games. Video games are really trying to get also all the part of accessibility, so this is a nice thing. We will arrive to that maybe sometime.
Interesting. So screen readers are difficult if you are not used them before. Any tips? Is keyboard test a good replacement? Is the keyboard test a good replacement?
Well, can be for something. But I think that the best advice for using a screen reader is be sure to know how to stop a screen reader before you start it, because the first time is very disruptive, let's say, but then you can try to use it. Obviously, I'm not using it like a real user, but some things are really obvious when you open it and listen for the first time. And screen readers are hard to use, and sometimes are not so usable, because you need to know some technical stuff to understand what a screen reader is telling you. And probably we should also work on screen readers and give screen readers a better usability. I'm not a real user, and I can do a lot of things. Sometimes I just write to a friend that is using a screen reader, and I'm not able to do that. Is inaccessible, or I am the one that is not able to do that? Sometimes it's me, sometimes it's the fact that I'm using just voiceover, and sometimes it's really inaccessible.
Thank you very much. We are out of time, but you answered all the questions. So thank you again.
Thank you. Thank you.
Ma la legge stanca sono sicura che ha festeggiato l'anno scorso i 20 anni. Sì, 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 era... Ma pensa che ci sono anche dei documenti ancora più vecchi in giro, di ovviamente perché cioè, l'idea è che Tim Berners-Lee quando ha pensato il web l'ha pensato fin da subito che potesse essere per tutte le persone, no? E quindi in realtà ci sono dei documenti in giro in cui parlano di accessibilità quando ancora le buche neanche esistevano. Ci sono molto belli. Sì, grazie mille, anzi.
Io è un tema molto vicino a me perché ho la mamma che ha difficoltà.
Certo.
No, tranquillo, sono tante volte. Ah, ok. Dico, io ormai sono vissuto.
Sì, sì, certo. Probabilmente
Thank you for coming to this last session before lunch. It's a pleasure to introduce Giovanni. He's a long-term Pythonista and friend here at PyCon, Italia. He's currently SRE, Software Reliability Engineer.
Wow,
at
nice
Sentry.
pronunciation.
If you want to know more about his work, his presentation, he has quite a few presentations on YouTube loaded in former PyCon Italian. You can see Granian, a Rust HTTP server for Python apps, PyCon Italian 2023. You can see Emmet, web framework for inventors, PyCon Italian 222. And why it still develops asynchronous web in the async.io era. Still on YouTube.
Yeah.
Okay, thank you very much.
Thank you. Hey.
Questions on Slido.
So, welcome to this talk. Yeah, I'm kind of surprised to see still a bunch of people to hear about async.io. So, briefly, who I am, I'm Joe. I stopped counting the years I'm working in Python because I'm getting old. So let's just say, yeah, long time Python developer. I'm working at Sentry right now, site reliability engineer. You know, I stopped discussing about product. I'm just my relationship is just with machines nowadays. I don't have to deal with people. Really nice. So this talk would be a bit different from what I used to do, because usually it's talking about what I did, which is kind of yeah, here's the thing, how you use it, how it works, done, 3 slides, super kind of annoying, right? So this talk is more about the journey that bring me to making an event loop in Rust. I thought it was more interesting. So ladies and gentlemen, welcome to a journey. But yeah, the journey starts with understanding a few things about async.io, especially given that, how many of you knows what happens when you await something? Okay, a few people. Let's see if you're right, though. So yes, before learning why I did what I did, I think it's interesting to understand what. So, but also given this is a journey, this might sound a bit me ranting a bit about how async.io is implemented. So forgive me for that. And also, another disclaimer, everything I say about event loops is valid only for selectors. So yeah, I'm sorry if you're on Windows, you have the proactor event loop. I don't really know how that works. So yeah, whatever. So first question: what's an event loop? Who knows what's an event loop? You want to try to answer? No, nobody. I can give you a hint. That's kind of how an event loop works. So yeah, an event loop is something that allows you to register yourself to watch for some events, I/O events. So let's say you want to read or write to a socket, okay? And so you say to the event loop, hey, I want to read, I want to write on this socket, and the event loop is a loop. Right? So you register, and at some point when that socket is ready for what you ask for, it will call you back. It's all about callbacks, okay? So event loops are a simple thing. Simple thing simple doesn't mean easy. It's simple, it's something that doesn't have any complex logic or stuff around, it's very simple. You register for something, and once that thing will be ready, you will call me back. Easy, okay? Sorry, simple. Not necessarily easy. You see, that's the problem with English. Everybody mix simple and easy. They're not the same thing. And it's also quite simple to understand why we want to use event loops, right? because we kind of want to do other stuff while we wait for that thing to happen, right? Like it's quite simple to understand why we want to use something like an event loop, because instead of like, I don't know, let's say picture like a restaurant, okay? You go to a restaurant and you place your order, and in a synchronous world, like the waiter will wait for your meal to be cooked before taking another order, which is kind of stupid, right? Like, hey, if I'm the 10th customer, should I wait like for all the customer before me to order and get the meal before even placing the order? Doesn't work, right? Like, it doesn't make any sense. So it's very clear, like, why we want a sync IO, why we want an event loop, so that we can do. It's not about doing more stuff. It's about doing something while we wait for something else to happen, right? It's like if you do your laundry and you make the washing machine, you load the washing machine. And in synchronous code, it's like if you wait for the washing machine to end, right? Like you just stare at it like forever until it's done, right? Like, hey, babe, got home. What did you do today? Laundry. Anything else? No, laundry. You know, like 3.5 hours per load. Like, just watch it. Yeah. So in essence, is to move from something like this to something like this, okay? Where we have this magic keyword and something happened in the background, but we don't care. Like, yeah, we do something else in the meantime. Which brings me to the next question, which is, what's a coroutine? Everybody wants to, anybody? No? What's a coroutine? Oh, you're going too hard. Slow down. Right. Because I had a hint also on this. It's a generator. Because in reality, if you go back in Python 3.4, we had yield from. Yield from, like, it was such a good syntax. Like, it really makes sense. Like, await doesn't mean anything. Yield from, on the other hand, you're generating something, but from something else. Okay? So, yeah. It was all about generators all the time, right? Okay? But yeah, now you know what a coroutine is. Can you do a sync IO with just a coroutine? No, sadly. You need something else, because again, like, you're yielding from something that will happen at some point, so you're kind of yielding from the future, a future, not necessarily the future, but you're yielding from a future. So hey, we need futures, okay? So yeah, and a future, like, it's a really good name, by the way. Like, it really makes sense, right? Like, you're yielding from a future. So let's call them futures. Makes perfectly sense, right? So now we have something else. So now we have like another object that can, so the coroutine like generate that, but then we have something that actually like makes the job, right? Like, hey, when I done cooking the milling, like that's how I tell a sync IO, hey, I'm done, you can go over, okay? So we now know about future. Is that enough to do a sync IO? No, not yet. Why? Because an event loop is a simple thing. It doesn't know about generators, it doesn't know about futures, doesn't, like, it's, again, it's just call stuff. It's a callback thing. So the event loop doesn't know about anything. So we need one last piece, which is control flow, right? Like, you have a generator that you need to iterate over the generator, and if a future returns from that generator, then you have to say, oh, okay, this is a future, right? So at some point it will be done, but you need this control flow to keep going, right? So how do they call that in Python? A task. Why a task? I have no effing idea. Like, that name doesn't make sense. It's not. It's control flow. whatever. Like they call them tasks. So to actually do async IO, we need tasks. So every time you use any async IO primitive, you gonna, if you read the documentation, yeah, if you pass a coroutine to that, it will be wrapped into a task. So it's everything about tasks. So at the end of the day, you have like the event loop calling these tasks. This is not the real implementation, but gives you an idea on how it works. So you have, like, the task is control flow. So it will iterate over the coroutine. Hey, I got a future, so now I tell the future, hey, when you're done, call me. Call me back so I can tell the event loop, hey, schedule another iteration. Call me again, okay? It's a loop. It's a never-ending loop. Like, event loop dot run forever, right? Like it's forever. So, congrats, Padme. You finally have a way to write and do async code in Python. And now that we know what, we can start asking ourselves, why? Why re-implementing an event loop? And why not? Like, there's nothing wrong with reinventing the wheel. I spent like the last 10 years of my life reinventing the wheel. Like reinventing the wheel is good. Like we kind of live in this strange moment of humanity where like it seems, hey, just tab, just use cursor and tab. Don't learn about anything, right? Like you don't need to know how stuff works, right? Like if just go fast, ship stuff. Don't understand the shit about it, huh? Right? So yeah, like I'm on the other side. I want to know how things works. Like face the same issue that other people face to learn to grow, right? So yeah, why not? But I also have like casus belli, or an excuse for that. Like I opened this on UVLoop. You know UVLoop? How many of you use UVLoop? Oh, a few people. Okay, you should use UVLoop. By the way, it's event loop, an alternative event loop implementation made in Python, relying on libuv, and I use it like for everything. So at some point, hey, free-threaded Python came out. Hey, I want to use UVLoop. No, I can't. I can't because they don't support it. So I open an issue. That issue is still there. Nobody showed up on that. Okay. So your next question would be, hey, why don't you do the thing yourself on UVLoop, like contribute to it? That's why. So it's like 13K lines of Python, and I don't know any Python. Like it's, I don't know, like it feels strange, like to write this strange code. Like it's Python, but it's not because it's C, but it's still like there's something in the middle. It's very complicated. So yeah, like let's say that contributing to UVLoop like requires a lot of knowledge, and also I don't know if you ever like looked at the libuv documentation, because this is how kind of feels, right? You start opening the libuv documentation, and my God, they do a bunch of stuff, which also means like if you want to use libuv, you really need to learn about it, right? And on the other hand, I know some Rust. Like some is the keyword part. You know, like you cannot say, hey, I know Rust. No. You just know some Rust, but I know some Rust, and I already maintain like few packages already made with Rust, you know. The core libraries for my web framework are made with Rust. GeoHasher is just a stupid tiny wrapper around like the GeoHash crate, but hey, it's fast. And I also maintain Granian. You should use Granian. Like if you don't know what it is, like it's a server, it's fast. Sorry, Marcelo, it's faster than UVcorn. I'm sorry. You should use it. Like try it. I'm gonna see with your eyes. And I also said like, how much hard would it be like to make an event loop? Like again, an event loop is something simple, right? So how hard it can be. Turns out it's not very hard. Like, I got the main logic in like a weekend. Like, just, you know, trying stuff. It works like in a weekend, got the thing. And again, like, it's something simple, like, because even like if you have, yeah, it's 1,000 line of Rust, but the actual logic, like the actual loop, is like 300 lines. Like, that's it. That's an event loop. Everything else is just, you know, APIs so that Python can understand stuff. And also, like, yeah. So let's say let's give you some reasons to use Rust. To write an event loop, like, it's a good idea, it's a bad idea. So let's see some reasons. So first reason, it's literally a loop. Isn't that cool? Hey, I said reasons, not valid reasons. Okay? Okay? Calm down. But yeah, more seriously, you have some really good friends in the Rust ecosystem. You have a few very popular library. PyO3 is amazing, by the way. But yeah, you have like Mio, which should be Metal.io, I think. Like, it's the actual name, but it's part of Tokyo, which is like everything doing async stuff in Rust uses Tokyo, right? Like, yeah, they try with some other thing, but at the end of the day, you use Tokyo. So you have like some strong foundations, and also like at the end of the day, like, that's it. Like, that's the line, one line that listens for events. That's the thing. That's it. The entire I/O is one line. So again, like in Rust, it's very easy to do something like an event loop. And also, like, you don't have to make any sacrifices on performance. At least for me, like, you have very few chances of footgun yourself. Like, I mean, like, being a good C developer, like, yeah, I started like with C, first language I ever learned, but like, yeah, I don't know. I'm not Linus, right? Like he knows C. I don't know. The chances to do like to shot yourself, like, it's too much. So in Rust, it's so much easier. Like, it's very hard to make like big mistakes in Rust, right? And it's also like less weird to me compared to Python, because again, like in Python, you have the Python part, the C part, but the C def, whatever, like, I don't know, just looks weird. But I also want to say it's not Rust versus Python. Like the whole thing is not about, you know, you should start writing Rust, right? It's more about, hey, we have some stuff that, like, just keep doing what you do. We just want to, you know, move some stuff into some more performance stuff, like keep the syntax, the amazing syntax of Python, the dynamism. It's just about, you know, some stuff. Let's make it faster. Downsides, like, it's a bad idea to use Rust to do an event loop in Python. I'd say like the constant maintenance switch between the two languages is kind of painful sometimes. And also, like, you end up having Rust code which is not really Rusty, like, you know, because all the Python stuff cannot have lifetimes or stuff like that. And especially, like, if you try to implement something which is made by the CPython guys. Hey, CPython guys, I love you guys. Like, you do an awesome job. But sometimes, you know, the design decisions of the internals of CPython. And here we go. So an event loop is something simple. But then we started adding layers of abstraction over it, right? Yeah, it's something simple, but we also want to, you know, have like this beautiful abstract interface that has to do a bunch of stuff. Which means if you want to implement an event loop in Python for async.io, you need to do like a bunch of other stuff, right? Like, yeah, the event loop is simple. The TCP stack is not. Definitely not. Like 60% of the lines just for TCP, really? Yeah, that's it. Next question. Does anybody know the difference between a protocol and a transport in async.io? So per documentation, so the official Python documentation states 3 different way of explaining that to you. And I don't know about you guys, but like when I see something that requires 3 different ways to explain, like it's not a good sign, right? I mean, but who cares? At the end of the day, you need them both. You need them both. Like for every connection, you need a protocol and a transport. Like 2 objects for every connection. So, yeah. Is that cool? I don't know. The event loop is simple. The abstraction layer, could be better. So yeah, at the end of the day, like if you really go deep dive like into async IO, you kind of look like that. So enough of rants, and then let's say the actual thing. So first things first, very alpha state. Don't use it in production. Like you can try it, but please don't use it in production because it works if you don't need a bunch of stuff. But it works, okay? And also, like, I don't really love to talk about features. Let's move to numbers, right? Like, you're here for the numbers, right? And that's why you're here. TCP, I mean, like, it took a while to write all that code, you know, all that implementation. But actually, it seems like, yeah, it's faster than both the standard lib, both UV loop. Not so much faster, right? Like you go from 2% to 18% on the standard lib, like 6% on UV loop. Like, yeah, it doesn't change your life, but still, it's I mean, it's performance for free, right? What about HTTP, right? Like, because everybody here is a web developer, right? So on Granian, which is my server, so it's easy. Like I already have like all the benchmarks for this, right? It's not faster than UV loop. Why? Don't really know. So at the end of the day, like, so Granian is a bit particular because it has a lot to do with threads. Like I need to call soon thread safe if you ever saw that line. So there's a lot more to investigate on that. UVCore, also not faster than the standard lib, not faster than UV loop. But this is macOS. Watch out. Because on Linux, UVCore, amazing, right? I did something and spent 1 month doing something that is 4x lower than the standard lib. Like, I don't know what's going on with UVCore on Linux. Man, yeah, we should sit together to see like what's going on. But yeah, anyways, I know like the one guy at the end in the last line have a question. Right? Right? There's Super Windows. But will it? I don't know, man. I don't know. So what's next? Near future, yeah, I implement all those features you need. Like, understand what's going on with UVCore, right? Like, but yeah, also like stabilize the Rust interface. So the idea is also like, if you do a Rust library, the idea is like you can use the event loop from Rust instead of Python, which saves you a bit of time. Remote future, a bunch of stuff, maybe Windows. Wanna contribute? Come over, we have cake. No, we don't, but you know. Final thoughts. Async IO is quite complex, but it's because of the interfaces we built on top of it. Like the event loop is something simple. Py3, magical. Like there's no other way to describe it. Like it's super cool. And also you can build like performance. Again, is 0.1 faster than the standard lib. Like hey, I'm faster than the whole C Python team that made the standard loop. Okay, and in a weekend. So again, like try Rust with Python. because it's very easy to do performance stuff, like even if you don't know shit about the language. That's it. Thank you.
Thank you, Giovanni. Works? Can you hear me? Thank you very much. Perfectly on time. We still have no questions, but I have a bunch.
Ask questions.
On Slido, remember.
Or just raise your hand, like just ask.
Or by hand.
So you mentioned that it's faster than the standard lib, in some cases faster than UV loop. Is it maybe possible that it is faster in many cases because it's simpler, because it is smaller? So the reason is not Rust necessarily, but the fact that you just do less things. Except in the HTTP stack, of course. There, I have no idea.
Yeah. So I don't know, because like the benchmarks are like row TCP echo, right? So and I had to like re-implement like the whole TCP protocol and transport stuff like from the standard lib. So on TCP, the amount of things I do is exactly the same, because otherwise like it won't work. Like that's the issue about doing something that should replace the standard library, right? You have to play with the rules that someone else defined, right? So maybe at some point that might be true, but right now, no. I think it's just because I don't know, it's Rust.
Also used Arc everywhere, so
yeah.
it's not heavily optimized.
I mean, it's Rust, and it's even like not performance Rust, because again, you have to arc everything, like box everything. Yeah.
Other questions?
If you're implementing the event loop from scratch in Rust, which I assume you are, wouldn't it be possible to use a different backend, for example, IO Uring instead of epool, for example?
Yes. Yeah, sorry. I was like a bit speedy on this one, but yes. One idea is also like in the future, like once I have like everything matching the standard lib, the idea is also to experiment with IO ring. Why not? Like, I mean, yeah, it's available only on Linux, only on 5.4, 10, probably better. But yeah, that's an idea, definitely.
Other questions? So I have one. Tell me you have a magic slide, extra slide with the 300 lines of code. I want to see the loop.
You want to see it? I mean, I can show you the loop, probably.
It's just because I like Rust. That's it.
Oh my God, this is super hard. Okay, here it is. But it's, yeah, from here to there. That's the loop.
Thank you very much. Enjoy your meal, your lunch.
Thank you, everybody, for showing up.
Ok, direi che possiamo iniziare dopo questa pausa pranzo con la prossima sessione. In questa sessione Luca Di Vita ci parlerà di cifrari fantastici e di come violarli. Grazie Luca.
Mi sentite? Mi sentite tutti? Ok, perfetto. Prima di tutto, grazie Santino, la vera esperienza del PyCon è essere presentati da Santino, ve lo assicuro, un onore. Allora, iniziamo subito, mi presento al volo, sono Luca Di Vita, ingegnere informatico, lavoro come Machine Learning Engineer e sono cofondatore della community Python Pescara e organizer per la community GDG Pescara. Se vi interessano le attività che organizziamo, a fine talk lascerò i QR. Allora, che cosa vedremo oggi? Come abbia detto Santino, sarà un talk sulla crittografia, rivolto per lo più sulla parte matematica e come si possono violare gli algoritmi come RSA o algoritmi come El Gamal, matematicamente parlando. E quindi inizieremo vedendo un po' quella che è l'importanza della crittografia, qualche accenno su crittografia simmetrica e asimmetrica e poi inizieremo con la carrellata di matematica che c'è dietro gli algoritmi di crittografia per vedere anche in quali casi riusciamo a violare questi algoritmi. Allora, prima di tutto, chi riconosce questa? Chi sa che cos'è questa? Ok, perfetto, bravissimi. Io allora ho qualche portachiavi, rarissima edizione limitata, quindi imperdibili, della community Python Pescara, quindi se partecipate, se rispondete alle domande, vi prendete un portachiave. Allora, sì, dunque questa è la macchina Enigma, macchina stata utilizzata per tanto tempo dai nazisti durante la Seconda Guerra Mondiale per inviare appunto dei messaggi cifrati, macchina che è stata violata da quest'uomo. Bravi, non mi potevate cadere su questa. Sì, è stata violata da Alan Turing, ma in realtà era stato aiutato con il progetto Bomba da dei polacchi, insomma la storia è particolarmente complessa. Come? Sì, la macchina, la bomba appunto. Quindi vabbè, con il suo team violarono appunto la macchina Enigma. Questi perché ho iniziato presentando queste due immagini? Perché sono rappresentative appunto perché, scusate la ripetizione, è importante studiare la crittografia. Vabbè, prima di tutto perché ovviamente noi vogliamo, per esempio, che le nostre conversazioni siano private, eccetera, eccetera, ma è importante soprattutto perché studiare la crittografia, capire come funziona, può cambiare potenzialmente il corso della storia. Okay? E non lo sto dicendo io che sto qua, l'ha dimostrato quest'uomo. Quindi studiate crittografia, mi raccomando. Allora, vediamo perché è così importante la crittografia. Beh, per diversi punti in realtà. Prima di tutto la confidenzialità. Noi vogliamo che le nostre informazioni personali in linea di massima siano protette. Se noi andiamo dal medico, ci aspettiamo che solamente il medico riesca ad accedere al nostro fascicolo sanitario e non chiunque. Per l'integrità. Vuol dire che quando noi inviamo un messaggio al nostro interlocutore, su WhatsApp, una mail, insomma quello che vi pare, questo messaggio arrivi integro, cioè che non ci sia nessuno nel mezzo a modificare il messaggio e quindi a far arrivare un qualcosa di diverso rispetto a quello che originariamente è stato inviato. Autenticazione, anche questo è un concetto molto semplice. Noi ci connettiamo su Facebook, non lo so, mi connetto come Luca Di Vita, chi parla con me si aspetta di parlare con Luca Di Vita. Molto semplice. La non ripudiabilità. Quando voi firmate, ad esempio digitalmente, non so se vi è mai capitato di firmare digitalmente contratti con banca o cose del genere, ecco, quella firma non è ripudiabile. Ci sono degli algoritmi che dimostrano che una volta che voi avete firmato un documento, quella firma è vostra, non potete dire no, non è vero, non l'ho fatto. E infine privacy, semplicemente vogliamo che le nostre informazioni personali rimangano tali. Allora, quando si inizia studiando la crittografia si inizia sempre da, diciamo, questo schemetto, cioè crittografia simmetrica contro crittografia asimmetrica. La differenza è molto semplice. Nella simmetrica, come vedete, Bob e Alice, che si vogliono inviare dei messaggi, utilizzano una stessa chiave. Quindi c'è un encoder, prende in pasto una chiave, un messaggio di ingresso, viene codificato e questo ciphertext viene passato poi al decoder che utilizza la stessa chiave per decifrare il messaggio. E già qua ci sta un problema. Qual è? Lo scambio delle chiavi. Santino, potresti portare il portachiavi a quel ragazzo con gli occhiali? Scusate, non è per discriminare, ma è il primo che ha risposto. Il problema, c'è appunto il problema dello scambio delle chiavi, nel senso come ti fornisco una chiave in maniera sicura. E Eva, che vorrebbe decifrare il messaggio, per leggerlo ha appunto necessità di questa chiave. Per quanto riguarda la crittografia asimmetrica invece è un attimino più complicata, c'è una coppia di chiavi, ognuno possiede una sua chiave pubblica e per definizione è pubblica, tutti quanti possono leggere questa chiave, ma anche una chiave privata. E la chiave privata, che è accoppiata in stretta relazione, come vedremo poi ad esempio nell'RSA, è in stretta relazione con la chiave pubblica, derivano l'una dall'altra, ma la chiave pubblica non dà nessuna informazione sulla chiave privata. Okay? Quindi noi la pubblichiamo sapendo che non si può risalire alla chiave privata a partire dalla chiave pubblica. Allora, come dicevo, c'è una coppia di chiavi, quindi Alice che vuole inviare un messaggio a Bob, scarica la chiave pubblica di Bob, cifra il messaggio con la chiave pubblica di Bob e invia questo messaggio cifrato. Bob riceve il messaggio cifrato, utilizza la sua chiave privata e decifra il messaggio. Quindi, vedete, qui non c'è uno scambio di chiavi. Quindi va da sé che è molto più sicuro come metodo. Allora, iniziamo ora a vedere la matematica che c'è dietro questi algoritmi. La matematica alle spalle di tutta quanta la crittografia moderna è la teoria dei numeri. La teoria dei numeri è una branca della matematica che studia le proprietà e le relazioni tra numeri interi attraverso alcuni concetti come fattorizzazioni, numeri primi e così via. In particolare della teoria dei numeri, che è un ambito un attimino più vasto, ad esempio la teoria dei campi anche fa parte della teoria dei numeri, noi però andremo a prendere l'aritmetica modulare. L'aritmetica modulare è una branca della teoria dei numeri che studia sì le relazioni tra numeri interi, ma lo fa attraverso il concetto di congruenza. Quando è che due numeri sono congruenti? Due numeri A e B sono congruenti modulo n se B è il resto della divisione intera tra A ed n. Okay, quindi facciamo divisione intera A diviso n, B è il resto, okay? E si indica con A congruente B modulo n. Qualche esempio giusto per capirci. Allora, 32 è congruente a 2 modulo 5, perché? Perché il 5 nel 32 quante volte ci sta? 6. Quanto avanza? 2. Quindi 32 è congruente a 2 modulo 5. 3 è congruente a 3 modulo 5, perché? Non ho sentito, più convinti? Esatto, perché il 5 nel 3 ci sta 0 volte e avanza il 3, 3 è il resto. 20 è congruente a 0 modulo 5, perché il 5 nel 20 c'è 4 volte per intero, quindi senza resto. Esistono le congruenze anche per numeri negativi, ad esempio meno 12 è congruente a 3 modulo 5, perché il 5 nel meno 12, qua è un attimino un po' più complicato perché si va per eccesso, e quindi si arriva a meno 15, e da meno 15 per ottenere il resto, diciamo da meno 15 a meno 12 ci passa un resto di 3. E ci sono anche le congruenze frazionarie, con le congruenze si possono risolvere anche delle equazioni. In questo caso, ad esempio, è un attimino più elaborato, si risolve con l'algoritmo di Euclide esteso, ovviamente non ve lo farò vedere, vi do giusto l'idea. Allora, qua, che cosa ci dice questa congruenza? Ci dice che l'inverso moltiplicativo di 1/3 è 2, cioè 2 moltiplicato 1/3 per aritmetica modulare, cioè 2 è l'inverso moltiplicativo di 3 in aritmetica modulare, cioè è quel numero tale per cui moltiplicato per 3 restituisce 1. Semplicemente nell'aritmetica normale, voi sapete, l'inverso di 2 qual è? 1/2, perché 2 per 1/2 è 1, e qua è la stessa cosa, però funziona con i resti. Allora, perché un terzo è congruente a 2 modulo 5. Perché? 2 per 3 fa 6. Il 5 nel 6 quante volte ci sta? Con il resto di 1 e l'inverso moltiplicativo. Quindi 2 è l'inverso moltiplicativo di 3. Allora, per risolvere le congruenze, quelle, diciamo, quelle più semplici, positive e negative, si utilizzano delle formulette molto generali, abbastanza semplici. Per quelle più complicate, come quindi divisioni, equazioni, si utilizza l'algoritmo di Euclide esteso. L'algoritmo di Euclide esteso, come dicevo, non ve lo presenterò per non essere troppo verboso, ma in poche parole permette di calcolare il GCD tra due numeri. Che cos'è il GCD? Massimo comune divisore, è il divisore più grande che due numeri hanno in comune. E quando due numeri non hanno divisori comuni se non uno, quei numeri si dicono tra di loro coprimi. Quindi ad esempio, GCD tra 8 e 15, vedete, non ci sono divisori comuni se non uno, e quindi 8 e 15 sono tra di loro coprimi. 12 e 18 invece il divisore più grande è 6 e quindi non sono coprimi. Perché questa carrellata di nozioni che sono anche piuttosto semplici in realtà? Beh, perché questo è, diciamo, questa stupidaggine, se vogliamo, e in realtà è uno dei pilastri che sta alla base dell'RSA. L'RSA si basa su due pilastri fondamentali e uno è questo, il GCD tra due numeri. Allora, già con queste poche cose che abbiamo visto possiamo iniziare a vedere un primo cifrario. Cifrario Cesare, penso che lo conosciamo tutti, l'ho portato solamente per riscaldarci o per rompere il ghiaccio, mettiamola così. È un cifrario simmetrico nel quale sostituiamo ogni lettera con la k-esima lettera successiva, quindi k è la chiave. E quindi ovviamente si richiede che questa chiave tra Alice e Bob sia scambiata. Qual è la legge di codifica? L'indice della lettera del testo cifrato è uguale all'indice della lettera del testo in chiaro più k, dove k è la chiave, modulo 26. Perché 26? Non ho abbastanza portachiavi per tutti, mi dispiace. Bravi comunque. Ad esempio, quindi, con k uguale 1. Quindi abbiamo 25 più 1, 26. 26 modulo 26 a cosa è congruente? 0. E infatti 25 diventa 0, z diventa A, così come A diventa B, B diventa C e così via. Per quanto riguarda la legge di decodifica è esattamente l'opposto. Quindi abbiamo l'indice della lettera del testo in chiaro è uguale all'indice della lettera del testo cifrato meno k modulo 26 e quindi 0 meno 1 diventa appunto meno 1, che in aritmetica modulare è pari a 25. Quindi meno 1 è congruente a 25 modulo 26, quindi 0 diventa 25 e quindi A diventa Z, B diventa A. Sostanzialmente stiamo tornando indietro, abbastanza semplice. Allora, per forzare l'algoritmo, il cifrario Cesare, in realtà abbastanza semplice. Al massimo abbiamo 26 chiavi, se vogliamo considerare anche lo 0, perché 0 vuol dire non cifrare il testo, però al massimo abbiamo 26 chiavi e quindi ci basta utilizzare un attacco a forza bruta. Complessità computazionale O grande di n, al massimo abbiamo 26 simboli, quindi andiamo lisci. Però, dai, vediamo un attimino, facciamo qualcosa di più impegnato, un modo più intelligente. Quello basato sull'analisi delle frequenze. Allora, l'analisi delle frequenze è importante perché in realtà tantissimi attacchi, anche il cifrario HIL, per esempio, si rompe con l'analisi delle frequenze, per dire. Allora, perché è importante l'analisi delle frequenze? Perché è utilizzata in tantissimi tipi di attacchi. In cosa consiste? Consiste nel vedere in una determinata lingua qual è la lettera che appare di più. Ad esempio, nell'italiano la lettera più utilizzata sono in ordine la E, la A, la I e così via. Quindi, se io vedo un testo cifrato con Cesare dove la L appare tante volte, vuol dire che probabilmente la lettera L sta cifrando la lettera E e quindi vuol dire che stiamo sostituendo a 4 stiamo sostituendo 11 e quindi ricaviamo la chiave facendo 11 meno 4 uguale 7 e abbiamo rotto il cifrario Cesare. Quindi questo è abbastanza semplice. Ora vediamo un pochino di codice, ma niente di trascendentale. Leggete tutti? Ok, questo l'ho rannato prima, almeno è più veloce. Ecco qui ho semplicemente conversione tra numeri lettere, lettere numeri. questa è l'implementazione del Cesare, ora lo riranno solo per far vedere che funziona, e gli do il mio testo. Ciao, mi chiamo Luca. Lanciamo, funziona, c'era dato il testo cifrato. Ora gli do la chiave 27 e come OP1, vuol dire che voglio decifrare utilizzando la chiave 27. Lancio, ok, perché funziona? Perché mi ha restituito il testo in chiaro se ho dato una chiave diversa da quello che avevo dato in partenza? Ok, bravo, ho capito che avete capito, sì, perché 27 è congruente a 1 modulo 26 e quindi 27 e 1 sono la stessa cosa in aritmetica modulare se considerato modulo 26. Quindi se io do un'altra chiave, vedete che non funziona. Ora, calcolo delle frequenze, pure qua definisco le mie funzioni, e io dico alla mia funzione, guarda che le lettere più utilizzate nella mia lingua sono la E e la A. Ti do il testo cifrato, dimmi quali sono le possibili chiavi. Lancio, ecco, come vedete, già qua, vedete o lo copro io con la testa? Okay. Già qua ci sta dicendo che una probabile chiave è 25, quella che cifra la E con la D, un'altra probabile è 3, quella che cifra la A con la D, l'ultima, guarda che un'altra chiave possibile è 1, quella che sta cifrando la A con B, ed era proprio la nostra chiave. Infatti qui, se vedete, testando con K uguale 1, abbiamo ripreso il nostro testo originario. Allora, sembra questo qui un attacco abbastanza stupido, abbastanza semplice, in realtà è estremamente potente, considerate che viene utilizzato anche per rompere il cifrario di Vigenère. Il cifrario di Vigenère è un'estensione del cifrario Cesare che ha complessità computazionale di 26 alla n, quindi con la forza bruta, già se avete chiavi di 10 elementi, non lo rompete più. Però riuscite a romperlo facilmente con l'analisi delle frequenze. Allora, iniziamo però con qualcosa di più impegnativo, perché magari insomma, il cifrario Cesare è abbastanza semplice e anche un po' noioso, no? E iniziamo introducendo i numeri primi. Quando è che un numero è primo? Anche qua concetto insomma, derivante dalla scuola, quando è divisibile solo per uno e per se stesso. Ora, i numeri primi, questa è una congettura che non è dimostrata, okay? Però i numeri primi non sono disposti in maniera randomica lungo l'asse dei numeri interi, ma sono disposti secondo la congettura di Riemann, che appunto è una congettura non dimostrata, ecco, non vorrei che si dica che è dimostrata. E niente, ci dice che ci sono sostanzialmente delle zone dove c'è un'alta concentrazione di numeri primi. Ad esempio, qui, queste zone più scure, ci dice guarda che in questa zona c'è una concentrazione alta di numeri primi. O qui, all'inizio, ci dice questo, molto semplice. Altra congettura molto importante, ma non dimostrata, è la congettura di Cramer. Congettura di Cramer che ci dice come sono distanziati, di quanto due numeri primi sono distanziati. E ci dice sostanzialmente che due numeri primi, Pn e Pn più 1, sono distanti tra di loro il logaritmo naturale di Pn al quadrato. Esempio, 1009, fidatevi che è un numero primo, logaritmo naturale di 1009 al quadrato è 48. Quindi quello che ci dice la congettura di Cramer è che il numero primo successivo a 1009 sarà al massimo, dove può essere, il successivo ovviamente no perché è pari, però sarà a 2, però al massimo sarà a 48, quindi può essere in range da 2 a 48 numeri di distanza. Quindi ci dice più o meno dove si troverà il prossimo numero primo. Allora, contrariamente a quando si pensa, immagino tutti voi abbiate sentito almeno una volta, se si dimostra la congettura di Riemann, allora tutta quanta la crittografia viene meno, eccetera, eccetera. Non è vero. Se si dimostra la congettura di Riemann e si dimostra la congettura di Cramer, tutta la crittografia moderna continua ad essere più che valida. La crittografia moderna, diciamo, è messa in discussione solamente dal quantum computing e comunque pure là abbiamo già degli algoritmi quantum resistant, quindi siamo abbastanza sicuri, ecco. Quindi quando vi dicono dimostrare la congettura di Riemann invalida la crittografia, sappiate che non è assolutamente vero. Questo perché Kramer e Riemann ci dicono la zona di dove sono concentrati i numeri primi, ma non ci danno una formula precisa per calcolarli, ok? Quindi se Riemann mi dice guarda che tra 10 alla 600 e 10 alla 601 ci sono tantissimi numeri primi, quindi cerca lì la chiave per RSA, e queste sono le dimensioni di RSA, 10 alla 600, cerca lì, ok, tu mi stai dando però 10 alla 600 numeri da cercare, insomma, è un attimino impegnativo, okay? Quindi la crittografia rimane valida. Teorema molto importante, teorema dei numeri primi, ci dice sostanzialmente quanti numeri primi ci sono più piccoli di un determinato numero. Ad esempio, 1000 ci dice, applicando questa formula, quindi 1000 sul logaritmo naturale di 1000, ci dice, c'è il risultato di 149, vuol dire che prima di 1000 ci sono 149 numeri primi. Altra congettura fondamentale, il teorema fondamentale dell'aritmetica, che ci dice che qualsiasi numero può essere scritto come prodotto di numeri primi. Anche qua io sto facendo una carrellata dei teoremi che in realtà sono abbastanza semplici. Questo però è il secondo pilastro su cui si basa RSA. Cioè si basa su questa cosa stupida, la 60 uguale 2 alla 2 per 3 per 5. Qualsiasi numero può essere scritto come prodotto di numeri primi. Ecco, RSA si basa su questo e si basa sul GCD. Quindi la potenza della crittografia, la bellezza e l'eleganza della crittografia asimmetrica la si vede proprio in questo, in pochi concetti semplicissimi che però sono estremamente potenti. Tutta la sicurezza che abbiamo nell'utilizzare, non lo so, nell'andare su Facebook o in qualsiasi sito dove andiamo, tutta quella sicurezza si basa su due concetti fondamentali. Allora, in tutto questo, perché si scelgono i numeri primi in crittografia? Beh, prima di tutto perché da Kramer sappiamo che i numeri primi, ok, sono infiniti, però diventano più rari al crescere in modulo, perché dalla congettura di Kramer sappiamo che più è grande un numero e più il successivo sarà distante, quindi più andate lontano e più sarà difficile trovare i numeri primi. Perché è computazionalmente oneroso calcolare i numeri primi. Ora, questo non è propriamente vero e ora lo vediamo. Però quando si parla delle dimensioni delle numeriche di RSA inizia ad entrare in gamba tesa questo problema. E poi semplicemente grazie alla loro proprietà, dovete vederla così, RSA non sarebbe mai esistito se non ci fossero stati i numeri primi, semplicemente perché l'aritmetica modulare abbinata all'utilizzo di numeri primi permette di avere delle equazioni che hanno una ed una sola soluzione, altrimenti 1 congruente a 1 modulo 26, 27 modulo 26, ancora è uguale a 1, quindi vuol dire che ad esempio abbiamo due soluzioni. Ecco, questo non è vero con i numeri primi. Per farvi capire un attimino le numeriche, allora, consideriamo un numero a 33 cifre decimali, okay? Quindi un numero dell'ordine di 10 alla 32 circa. Ora, dal teorema fondamentale dei numeri primi, se andiamo a fare calcolo x sul logaritmo naturale di x, abbiamo che più piccoli 10 alla 32 ci sono 10 alla 30 numeri primi. Ora, un calcolatore moderno riesce a testare 10 alla 9 chiavi circa al secondo e quindi 10 alla 30 su 10 alla 9 per testare 10 alla 30 chiavi impiegheremmo 10 alla 13 anni, ok? E il tempo stimato di vita dell'universo è 10 alla 12 anni, con chiavi a 33 cifre decimali. RSA utilizza chiave a 2048 bit, vuol dire che sono numeri a 617 cifre decimali e vuol dire che sono numeri dell'ordine di 10 alla 616, quindi per farvi capire le dimensionalità di cui si parla. Allora, come facciamo a verificare se un numero è primo? Soluzione naive, crivello di Eratostene, sì, l'ho scritto male, Eratostene, a complessità computazionale o grande di radice di n, quindi è un subesponenziale, in realtà è un problema anche abbastanza veloce, però sfido io a testare i numeri di 10 alla 600, quindi con queste numeriche anche radice di n è improponibile. Ci sono poi altri, diciamo, test più intelligenti, come il test di primalità di Fermat o il test di Miller-Rabin. Qua vediamo quello di Fermat perché è un attimino quello più semplice, più intuitivo. Ci dice questo: un numero P è probabilmente primo se A elevato alla P-1 è congruente a 1 modulo P. Se non è vera questa congruenza, allora il numero è sicuramente composto, che quindi vedete la differenza. Se la congruenza non è vera, sicuramente stiamo parlando di un numero composto. Se la congruenza è vera, forse il numero è primo. Consideriamo l'esempio con più uguale 11, quindi numero primo, lo sappiamo. Allora, un A scelto a piacere, 2 alla 10 è congruente a 1 modulo 11. Se vi fate i calcoli vedete che è vera questa congruenza e infatti 11 è un numero primo. E per più A eseguite questo test, più il vostro test sarà accurato, quindi sarà affidabile. Perché è un test probabilistico? Perché ci sono alcuni numeri noti come numeri di Carmichael che rendono vera questa congruenza anche se il numero non è primo. Ok, ora possiamo iniziare a vedere un primo algoritmo. Abbiamo tutti quanti gli strumenti per vedere un primo algoritmo. RSA, Rives, Shamir, Adelman, sono gli sviluppatori appunto di RSA, è un algoritmo asimmetrico e la sua difficoltà si basa proprio sul fattorizzare numeri molto grandi nei suoi fattori primi. Quello che vi ho detto prima, teorema fondamentale dell'aritmetica, okay? Trovare i numeri primi che fattorizzano un numero. Ecco, RSA si basa proprio su questo. Vediamo quali sono i passi. Abbastanza semplici, sono 1, 2, 3, sono 6 step, quindi niente di particolarmente complesso. Allora, Bob sceglie due numeri primi, P e Q, e calcola, no, questa non è Φ, mi ricordo, vabbè, il totiente, che è uguale a P-1 per Q-1, e calcola N, che è uguale a P per Q. Poi si sceglie anche un esponente E, tale per cui il GCD tra E e il totiente sia 1, e qua ritorna quello GCD che vi dicevo prima, il secondo pilastro di RSA. E infine si calcola una D, che è l'inverso moltiplicativo di E, quindi una D tale per cui D per E è congruente a 1 modulo Φ. E in realtà abbiamo già creato la nostra coppia di chiavi, perché N, che è P per Q, ed E, l'ha calcolato qui, è la chiave pubblica, mentre P, Q e D sono segreti. D in particolare è la chiave privata, perché la utilizziamo per decifrare, e ora vediamo come. Quindi Alice che fa? Scarica la chiave pubblica di Bob, quindi scarica la coppia N che è pubblica. Converte il suo messaggio in numeri, e quindi M è il suo messaggio, e calcola M alla E modulo N. Quindi abbiamo la nostra C che che è congruente a M alla E modulo N, e invia questa C a Bob. Ora Bob riceve C, quindi vuol dire che sta ricevendo M alla E, ed eleva M alla E per D, che è la sua chiave privata. Okay, quindi fa M elevato E elevato D, ma per la proprietà delle potenze M alla E elevato D è pari a M alla E per D, ma D è l'inverso moltiplicativo di E, e quindi E e D si elidono, e quindi da C Bob riesce a risalire al messaggio M. Allora, ci sono diversi modi per attaccare RSA, si possono fare attacchi agli oracoli, eccetera. Ci sono tanti modi. C'è il quadratic sieve, che è un numero estremamente efficiente, quindi se voi pensate che numeri dell'ordine di 10 alla 100 siano numeri sicuri, non è assolutamente vero. Il quadratic sieve riesce a rompere RSA se ha delle chiavi dell'ordine di 10 alla 100. Un attacco interessante è l'attacco low exponent, è un attacco che si basa non su una misconfig, però una scelta sbagliata dei parametri, in particolare del parametro E. Perché? Se scegliamo il nostro parametro E, tale per cui quando andiamo a calcolare la D, che è l'inverso moltiplicativo di E, D rispetta questa condizione, cioè viene sensibilmente più piccolo della chiave, viene sensibilmente più piccolo di N, secondo questa, si dimostra che questa formula è così, allora RSA calcolare D richiede tempo logaritmico, o grande di log di n, quindi estremamente veloce. Questo metodo si basa sull'utilizzo delle frazioni continue. Le frazioni continue, ora non mi addentro troppo, però è un metodo iterativo che permette di approssimare numeri irrazionali attraverso appunto divisioni intere successive. Ad esempio, pi greco può essere scritto come 3 più 1 su 7 più un quindicesimo. Vedete che approssima il pi greco già al terzo livello, lo approssima molto molto bene. L'attacco si basa proprio su questo, vediamo perché. Allora, noi scarichiamo Eva, che vuole decifrare il messaggio, scarica la chiave pubblica di Bob e calcola E su n. Sono valori che prende dalla sua chiave pubblica, quindi lo può fare. Però questo E su n lo calcola con il metodo delle frazioni continue e quindi ottiene di fatto una frazione con numeratore A e denominatore B. Ora, Eva si calcola questa C che è uguale a E che prende dalla chiave pubblica per D, che è il denominatore del metodo delle frazioni continue, meno 1 su K, dove K è il numeratore del metodo delle frazioni continue. Se C non appartiene all'insieme dei numeri naturali o C non è dispari, allora si torna allo step 1 e si incrementa il livello delle frazioni continue. Quindi qui è come si aumenta un'altra volta il livello di frazioni. Altrimenti va allo step successivo qui, e risolve queste equazioni di secondo grado. Ora, non l'ha detto perché ci metto più tempo a leggerla che ad altro, però sono tutte informazioni che ha, perché n l'ha scaricata dalla chiave pubblica, C l'ha calcolato di qua, il resto sono variabili che ha messo Eva, le incognite, scusa, che ha messo Eva, e se la soluzione di questa equazione di secondo grado, le soluzioni, scusate, sono due numeri naturali, allora quei due numeri sono quelli che fattorizzano n, cioè n sarà pari a R1 per R2, che sono le soluzioni delle equazioni di secondo grado. Se invece se non funziona, invece, si ritorna allo step 1 e si ricomincia con il metodo delle frazioni continue. Ora, anche qua possiamo vedere un esempio. Scusate, devo un pochino accelerare. Okay, qui le chiavi le ho messe io per dare una parvenza, per farvi vedere che funziona anche con chiavi un po' grandi, però queste chiavi le riesce a risolvere anche la forza bruta. Allora, ecco, vediamo qui abbiamo calcolato la nostra coppa di chiavi, ma vediamo già un qualcosa di strano, perché vediamo, scusate se è mosso, ok, vediamo che D è estremamente più basso di n e quindi probabilmente riusciamo ad applicare il metodo delle frazioni continue, e infatti è quello che ho fatto. Beh, qua una carrellata di attacchi, quindi... Ok, vedete che con 8 tentativi siamo riusciti a fattorizzare n, vuol dire che abbiamo trovato P e Q e vuol dire che possiamo risolvere le equazioni di RSA all'indietro e possiamo ricevere tutta la conversazione. Volendo possiamo testare anche con la forza bruta. Funziona perché con queste chiavi piccoline, vedete però che ci sta mettendo un attimino di più, comunque fa subito, però ha impiegato un po' di più di 8 tentativi. Ok, allora io direi iniziamo quindi con l'ultimo algoritmo di crittografia, vedremo l'algoritmo di Al-Gamal, che si basa sul logaritmo discreto. Prima di vedere il logaritmo discreto, un breve recap su che cos'è il logaritmo. Perdonatemi, i puristi della matematica, perdonatemi, ma il logaritmo è l'inverso dell'esponenziale, può essere visto come l'inverso dell'esponenziale, quindi qual è quel numero che dobbiamo dare a x, qual è quel numero a cui dobbiamo dare a x, tale per cui 10 alla x uguale 1000, in questo caso 3. Logaritmo naturale in base 10 di 1000 è 3. Logaritmo discreto è la stessa cosa, però dovete ragionare con i resti, quindi alfa alla x congruente a b modulo p, cioè qual è il numero che dobbiamo dare a x tale per cui alfa alla x è congruente a beta modulo p, cioè quel numero tale per cui alfa elevato x diviso p dà come il resto beta, e questo è il logaritmo discreto. Vabbè, poi ci sono alcune proprietà che ora non entro nel merito, e consideriamo questo esempio: alfa uguale 2, beta uguale 9, p uguale 11. 2 alla x congruente a 9 modulo 11. Qual è la soluzione? 6. Perché? Perché 2 alla 6 è 64. 11 quante volte c'è nel 64? Daresti in portachiavi a quella ragazza? Dietro Paolo. 5, con il resto di 9. Okay? Quindi risolve il logaritmo discreto. Ora, già con numeri molto bassi bisogna un attimino ragionarci su come si risolve il logaritmo discreto. È un'operazione molto difficile da risolvere per numeri alti, e su questo si basa l'algoritmo di Al-Gamal. Quindi l'algoritmo di Al-Gamal è un algoritmo asimmetrico che si basa proprio sulla difficoltà di risolvere il problema del logaritmo discreto. Come funziona? Si sceglie un numero primo p, una radice primitiva, non sto spiegando che cos'è una radice primitiva alfa, e un esponente a. e si calcola beta congruente a alfa alla A modulo P. Quindi la nostra chiave è P alfa beta, quindi questa terna, e manteniamo A segreto. Quindi P alfa beta è la chiave pubblica, la chiave segreta di Bob è A, cioè il suo esponente sostanzialmente. Alice che fa? Scarica la chiave pubblica di Bob e utilizza tutti quanti quegli elementi, quindi si calcola una sua chiave segreta K e calcola R congruente alfa alla K modulo P e calcola T congruente a beta alla K per M modulo P, dove M è il messaggio che sta quindi nascondendo all'interno di queste operazioni. K viene mantenuto segreto e invia a Bob RT. Quindi il messaggio cifrato nell'algoritmo di Elgamal in realtà sono coppie di numeri, ok? Non è uno stringone di numeri, non è un listone di numeri, ma è un listone di coppie di numeri. Ora, qui non faccio tutti quanti i passaggi come prima con l'RSA, però tramite operazioni inverse, se fate le sostituzioni con R e con T, tramite operazioni inverse vedete che Bob, che riceve la coppia RT, eleva alla potenza di meno A il prodotto da T per R, e tramite operazioni inverse riesce a risalire al messaggio in chiaro per passaggi matematici. Allora, come si attacca l'algoritmo di Elgamal? Ci sono anche qua diversi attacchi, baby step, giant step o l'attacco del compleanno. Ho portato l'attacco del compleanno perché è quello più interessante. Chi ha mai sentito parlare del paradosso del compleanno? Bravissimi, bravi tutti. Allora, il paradosso del compleanno è un paradosso probabilistico che dice sostanzialmente che in una stanza con almeno 23 persone c'è il 50% di possibilità che 2 persone fanno il compleanno lo stesso giorno. Okay? Quindi qui ad occhio e croce saremo un po' di più di 23, quindi c'è un'alta probabilità che 2 di voi facciano il compleanno lo stesso giorno. Perché è un paradosso? Perché è molto controintuitivo se ci pensate, sono 365 giorni, come cavolo è possibile? Però sta di fatto che è così. E questo numero addirittura arriva al 97% se saliamo a 50 persone. Quindi con 50 persone è quasi certo che 2 persone fanno il compleanno lo stesso giorno. Allora, quindi come utilizziamo questo paradosso? L'idea è semplice, l'idea è faccio una ricerca dell'esponente in maniera, diciamo, allora ricerco in un range di esponenti, ora vediamo come, perché è probabile, anche se è poco intuitivo, è probabile che l'esponente che cerchiamo è lì, proprio come il paradosso del compleanno, okay? Anche se lo spazio è molto grande, la matematica ci dice che in realtà, come abbiamo visto, 2 persone fanno il compleanno lo stesso giorno con un'altissima probabilità, ed è la stessa cosa per cercare la chiave X. Vediamo perché. Allora, quello che fa l'algoritmo di Elgamal è il logaritmo discreto, okay? Quindi sostanzialmente dobbiamo risolvere questo di base. Allora scriviamo 2 equazioni molto simili ma differenti. H per g alla meno x1, dove x1 va da 0 a parte intera di radice di p. E risolviamo g alla x2 modulo p, dove x2 va da 0 alla parte intera di radice di p. Quando abbiamo quella che si definisce una collisione, cioè h che moltiplica g alla meno x1 è congruente a g alla x2, cioè sono sostanzialmente uguali, allora abbiamo risolto il logaritmo discreto, perché sarà pari a x1 più x2, giusto per farvi capire meglio. Consideriamo numero primo p 23, la parte intera di radice di p è 4 e supponiamo di avere un h e g tale per cui g alla x2 è uguale a 1 se x uguale a 1 se x2 uguale 0, a 5 se x2 uguale 1 e così via. H che moltiplica g alla meno x1 è uguale a 10 se x1 uguale 0, 22 se x1 uguale 1 e così via. Come vedete qui c'è una collisione perché 10 appare sia qua che qua e quindi vuol dire che g alla x2 con x2 uguale 3 è congruente ad h per g alla meno x1 con x1 uguale 4 e quindi abbiamo risolto il logaritmo discreto perché x è uguale a x1 più x2, cioè a 3 più 4 è uguale a 7. Dire 7 è la soluzione al logaritmo discreto e quindi ci permette di rompere appunto il cifrario di Elgamal. Anche qui ho portato un esempio. Allora, qui i numeri anche li ho dati io perché prendere un numero che sia radice primitiva è tutt'altro che, insomma, che banale, e quindi li ho scelti io a priori. Però vedete, quindi chiave pubblica, come dicevo, la terna, e la nostra chiave privata che è 56. E come dicevo, il ciphertext è una lista di coppie. Vedete che la decifratura funziona, proviamo ad attaccarlo, quindi con l'attacco del compleanno ho implementato anche forza bruta, baby step, giant step. Attacco del compleanno, 26 tentativi, quindi bene. Attacco a forza bruta, testiamo tutto, e quindi 57 tentativi, da 0 a 56. 56 era la soluzione, quindi ok. Baby step, giant step. Dopo 2 tentativi è riuscito a rompere il cifrario del Gamal. Ok, in realtà quella era l'ultima slide. Ah, ok, sono anche perfettamente nei tempi, quindi grazie a tutti quanti per l'attenzione e vi lascio il QR con i gruppi. Grazie.
Grazie Luca per la presentazione. Se ci sono domande qui in sala, lasciamo il tempo di fare la scansione.
Sì, in questa cartella Drive trovate anche altri tipi di attacchi. Ci sta il cifrario HIL, c'è un attacco alla firma, c'è l'implementazione di una curva ellittica, quindi insomma ci sta più materiale di quello che ho mostrato. Qui ci sono i miei riferimenti, blog, Instagram, LinkedIn, se volete contattarmi per qualche motivo, e se non ci sono domande, ok, forse ce n'è una là. Fuoco amico, maledetto.
In quale meetup possiamo sentire altri talk interessanti come questo?
In quale, scusa?
Quale meetup? Python meetup ti troviamo?
In questo qui. Nel Python Pescara. Penso che la risposta giusta sia questa, quindi mi raccomando unitevi ai gruppi, perché poi è lì che pubblicizziamo i nostri eventi. Però sono di persona, quindi dovete venire a Pescara, vi tocca.
Mi chiedevo se un LLM potesse aiutare un malintenzionato a risolvere con più facilità cose del genere.
No, sono operazioni troppo... I numeri sono troppo grandi, penso che 600 cifre decimali, no, sì, te lo riesci a gestire, però non ti riuscirebbe a gestire la moltiplicazione di 2 numeri dell'ordine di 10 alla 600, quindi no, non ce la farebbe l'LLM. Altro?
Okay.
A te non te lo do il portachiavi perché te l'ho già dato. A Matteo.
Ho visto nel messaggio cifrato c'era anche punto esclamativo, 2 punti,
Sì.
Quindi non so, di solito si aumenta, cioè è
Sì, no, ho
comune
fatto
avere
io,
anche...
se vuoi riprendo il notebook, però ho fatto io semplicemente un parse tra i simboli e i numeri, cioè nel senso non ho messo solamente le lettere, di solito si levano i simboli, io ho aggiunto, quando ho fatto la conversione con i numeri, ho aggiunto semplicemente anche i simboli, quindi ho preso tutte le lettere dell'alfabeto, compreso i simboli, e ho fatto io una conversione in numeri di tipo 00, 01 e così via. Portachiavi per favore, Santino.
Sì. Ok. Grazie Luca.
Okay, so we'll start. So, first of all, thank you guys for joining us here. And so today we have with us Rami, and he'll be talking about exploring functional options in Python. So I'll just let him talk. Just a round of applause for him first of all.
Hello, everyone. It's very intimidating to be here, following up all of our amazing speakers. I think, all the accomplished engineers that talked at this conference, what I've done in my life does not even compare. But thankfully, I'm not here to talk to you about some hardcore tech that I invented, like SPy or something. I'm mostly here to entertain you, and hopefully you can go home with a thing or two learned along the way. So show of hands, who's used a function that looks like this before in their life? I'm sorry for you all. I think a lot of people have used this because it's from a very well-known ORM that is very widely used. And it doesn't even get better as you scroll through their docs. This is their description of these parameters. And I think that this was just a natural evolution of what started off as simple code that got the job done. But then people kept adding to it over time, and it got to this point. And we can't really judge grass for overgrowing, We can't judge project requirements for evolving over time. It just happens. But at some point, you need to maintain them to keep them usable and in a good shape. And this is where garden tools and software design patterns help us. Like mowing the lawn with an electric lawnmower is a lot more efficient and easier than doing it with an old school scythe, even though scythes are making a comeback on YouTube nowadays. It's pretty nice to watch, I'm not gonna lie. So what are we doing today? We're gonna be exploring a problem and designing a solution that satisfies us. And we'll also be thinking about this design process together and judging each design we come up with. By the end of the talk, you'll go home with a couple more tools in your tool belt and some extra experience with designing good code, and also a reminder to check out YouTube videos with people mowing their lawns with scythes. I think it's time I introduced myself. I'm Rami, I'm a full stack engineer. I work a lot in AI, and I've been designing solutions like the one we're about to work on for a while and across domains. I'm also an open source maintainer of a few projects, notably Dataline, which is the latest. It's an AI-driven, privacy-first platform where you can query your data and explore it. And also PET, which is a simple command line snippet manager written in Go. This was a project that also I used for many years and very randomly became the maintainer of. And on Saturdays, you can spot me screaming while wielding a shinai. It's called Kendo. It's very fun. I can recommend it. And just yesterday, actually, some friends I train with got 3rd place in the European Championships. So I'm extra happy today. First, let's start with a story. I'm going to tell you the story of Sam, who is a smart engineer and good designer. And Sam's company wanted him to design a document analysis web service client. It supported all kinds of documents as well as OCR. OCR is optical character recognition, for those of you who don't know, and it extracts text out of images, basically. And Sam was tasked with building a simple Python client for interacting with this service. The only requirement was to support text files, so none of the advanced service features were needed yet. So Sam goes ahead, starts with this task, and creates a simple function to call it. So we have a file, we have a couple of parameters, and a small doc string that explains what each parameter does. It's simple, right? Given the requirements, it gets the job done. I think this is a great design. And this is an example of its usage, where we're constructing the headers as a dictionary, and then based on each parameter, we're populating the dictionary and then creating a simple post request to the server. And now let me introduce a little activity that we're going to do together a few times in this talk. I call it a crowdsourced code review, although limited in dimensions. So we're going to judge the code together along these 3 dimensions: documentation, validation, and reusability. If you think the design does well in a certain dimension, I want you to raise your hand. If you think it's bad, just don't raise your hand. And then I look at you and, come up with a number that's not a binary number. And then I show you what I thought and why. And we can't really quantify code designs as they're, more craftsmanship and art, but for the sake of this presentation, we're going to accept the oversimplification. And I'm going to show you the code one more time, but in the next examples, try to think about this judgment as we are walking through the code. So for this one, what do you think, how do you think about its documentation? Raise of hands if it's good, don't raise your hand if it's bad. Do you want me to show you the example again? So this is the example, and these are the docs. And then we're also going to look at its reusability. So what do you think about the docs? Good? All right. And validation doesn't really apply here because we didn't do any validation. And what do you think about its reusability? All right, not so reusable. Here's what I thought. So kind of in line with what you guys thought, sorry. I think it's a pretty good design. It's simple. The documentation does its job because we just have 2 arguments. And we don't have validation. It's not very reusable because it's just a function. So we can't really copy-paste the parameters as easily as an object, for example. So Sam delivers his work and everyone's happy. But a few weeks later, to no one's surprise, the project manager comes back and tells Sam, we need to add more to this. We want to support PDFs and images. We want timeouts for long analyses. And we want to find the bounding boxes of extracted words and more. So Sam decides to keep it simple and just extend this function first before we overcomplicate it and try to come up with a better design or whatever. Let's see what we're dealing with. And so he does that. I'm going to walk through the code without commenting on it much. So we have a bunch of parameters. There are a lot more parameters. And the docstring has also grown a lot because it needs to describe every one of them. And then we're constructing a headers dictionary based on each one of these parameters. Here you see we also have some validation. We want timeout to be an integer. We want it to be positive. And we want to check that the rotate angle is within something. So it's just to illustrate the point. And then we also have sub-options. So if OCR is enabled, we have some other options that only apply if it is enabled. And so this is, getting much bigger because it's just extending the function. The post is still the same. The usage is also just a function call. So still very simple to understand. Now, code review time. What do you think about the documentation? Raise your hands if you think it's good. Okay. Sketchy hand raises, but what about the validation? Okay, about 20%. And what do you think about the reusability? Okay, 0 hands. Very non-reusable. This is what I thought. I thought the documentation is not great because I'm also looking at it from a context of the code editor. So if I'm someone who's using this function and I want autocomplete, I'm going to get a massive docstring that I need to literally scroll through in the code snippet. So to me, that's not great docs, even though we are documenting every one of these arguments on its own. And the signature is pretty big, and the body is mixing validation with construction. So it's really, mixing responsibilities there. And it grows with the number of arguments, which is not great. Like this is maybe acceptable, but imagine you have a lot more options. And in reality, this is actually reflecting a real server from Apache called Apache Tika. And there are many more options. And I wrote this presentation when I was actually building a client for that web service. And so Sam doesn't like this at all. He thinks it breaks the golden principle, which is not leaving things worse than you found them. One second. So I think this principle is essential to living well. from writing good code to keeping your kitchen clean. Like it all goes back to the same thing, a mentality of caring about these things and maintaining them even if you don't feel like it. Like if you finished your dinner and you leave your plate in the sink, it's going to be 10 times harder to clean the next day. But if you just rinse it off or put it in the dishwasher, then you did some tiny maintenance, but you made your life a lot easier and you left the kitchen in an equally bad state, at least not worse. And so over time, I think this does matter and it does add up. So I think our code review also agreed with like my opinion, and we can improve upon this. And so Sam decides to iterate on this. So first of all, improvement ideas. We can separate the validation and construction. That's a simple win. And we can improve the reusability by having an object of options. Then we can pass the object around instead of having a bunch of arguments. And we can also get documentation per argument. Optimally, that would be what I want, because now I have to scroll through a big paragraph of docstring. I would like to have localized documentation. So I'm looking at parameter X. I want to see the documentation for parameter X. And these are the improvements we have in mind. And now keep in mind, we're talking about like all these improvements and how these docs are bad, but this doesn't even have a docstring. So just to give you some context, I had to double check, but even in their source code, there's not even a docstring describing what these parameters do. There's just a mention of these parameters. So I think we're still good, even though we're trying to improve further. And so Sam thinks of config classes. Why don't we use a class that handles these fields and maybe also handles the validation for us? So something like Pydantic would be a good fit here. We still have a big docstring, so that didn't improve much. Oh, I shouldn't comment on the code yet. And we have the fields, each one with its type, and then we have some validators which are defined using the Pydantic field validators. So the validation logic is now separate. We're still doing the construction as we used to before, and we still support the sub-options. So now if the with OCR is set, only then do we check the sub-options here. I think the sub-options, oh, I shouldn't comment yet, again. And the getText function, we're just constructing the class and calling two headers and passing that into the request.post. So what do we think of this, documentation-wise? Okay, not too bad. What about validation? I think there was a big improvement in validation. And reusability, also more reusable. Okay, here's what I thought. I think the validation was definitely much better because now it's separated and we can push it even further by using inbuilt Pydantic validations. In this case, we're still doing it manually just for illustration. And the reusability has improved because now config is an object and we can pass it around easily. And the docs are kind of the same still. It's one big docstring which comes with the same disadvantages that we mentioned in the previous design. But yeah, in general, much better looking against our metrics. So can we do better here? It's good, but it's still lacking. I think it's sad to have a solution that doesn't self-document well, especially that given that this is a client for others to use. Like it needs to be self-descriptive, otherwise it's going to be very hard for other developers to use this code. Coincidentally, Sam is also a Go developer. And in Golang, we have a much more standard solution to this than we have in Python. And it's called functional options. Options is because we're passing parameters to a function, options. The functional part, well, you'll soon find out, but I'll give you a spoiler. It doesn't have anything to do with functional programming. So he wonders if he can translate that design from Go into Python and reap the same benefits that this design has in Go. And to show you what this design is, we're going to look at the end result first. And this is basically what functional options looks like. So we have a getText function that takes in the file, and then we have an options class. And then within this options class, we have a few static methods. So with timeout, and that can take arguments. And then you can see the with OCR now. This one's a bit more interesting here because you can see the fact that sub-options are represented. And with rotation also can take arguments. So having functions for each one of the options is a lot more flexible because now we're going to get, a lot more control over each one of these options construction. And let me show you now how these methods actually work. It's going to be a bit weird, so bear with me. But yeah, you'll get a chance to review it in a second. So each one of these options returns a function. So you can see here we're returning a callable, which is apply, that itself takes in an options dict. So it's very weird once you first see it. Even Go developers find it very weird when they first encounter it. In the with timeout, you can see we have the validation in one section, and we also have the function getting returned and applied on the options dictionary here. And with OCR, same thing. We also have its own docstring, and it returns a function that applies these sub-options based on which ones were passed in. And this is how we loop over the options and apply them to the headers. So we start with an empty headers object, and then each option is called on top of the headers because each option is a function. Hence the name functional options. And this is the usage again. So what do you think about this one, documentation-wise? Good, bad? All right. I think the documentation for this one is so good that I had to add a screenshot for the editor autocomplete, because as you're filling it in, you can get the documentation that's only pertaining to the argument you're trying to fill out now. So it really breaks down that massive docstring into sub-docstrings, and then they're localized to where they're needed. What do you think of the validation? All right, maybe a little step back. Reusability. Okay. I think it's also the same reusability-wise because we're kind of still passing around an object, although maybe a bit improved because now each option is defined separately. I think the validation is a bit less good because we don't have Pydantic anymore, so we don't have the power of the internal validators, and we're mixing it with the construction a bit again, but it's still not too bad. But there is one thing about it, though, that I think you all saw and probably felt that isn't described in our metrics. I think it's a bit too complicated and not Pythonic, right? Like we're returning a callable and we have to loop over the options and apply them. Like it's hard to use and also hard to define. So there has to be like something that we can do about it to improve it. And this also shows us the weakness of like using such metrics because you can't define everything and quantify everything. Like there is a craft to it. And so this is what I thought and I just described. So from here, Sam was thinking about the solution to his problem, and then inspiration came to him from an unexpected place. So JavaScript, it's given us a lot, and I say this only half sarcastically maybe, but one thing it's especially recognized by is method chaining. You see it everywhere in JavaScript, and Sam being a JavaScript nerd, his functional options implementation made him think of method chaining, like seeing these methods defined one after another, but separated with a comma instead of a dot. And this is kind of common in Python too, like it's not specific to JavaScript at all, it's just well known there. And I think some of you know where I'm going with this already. So builder and chain is a software pattern that allows us to build an object incrementally by chaining method calls together. And this is how you would apply it in this case. So now we're constructing one options object and then calling methods on that object. And so everything is now contained within options. We're still reaping the benefits of functional options because we still get the documentation advantages and each one of the options is still a function, but it's now, a bit more standard to Python, let's say. And looking at the implementation, you can see that we have an internal state, which is options. So now the options class is handling this for us. We don't have to handle that outside. And then each one of these functions will just manipulate this internal state based on what arguments you give it. Same for the rotation. And then in the build, we're just returning the internal options just to give it like a nicer interface to the outside world. So Sam is pretty happy with his choice at this point. It's Pythonic, it's the best iteration so far, and I think we can skip the code review on this one because it's pretty similar to what we had in functional options, except it's simpler, which is an advantage. So I think it's still, not exactly the same thing as before. The metrics we had for the review didn't all improve, and they didn't all decrease. So this is the thing with designs, they're all very unique and special. But then why is it used in Golang, since it's so complicated and twisted? Are all Gophers wrong to use this? Are they missing something simpler, like method chaining and builder and chain pattern? Why is that not used there? And I think every time we ask ourselves a question like this, it's better to assume that we're the ones who are wrong, because the people who worked on Go are incredibly smart people, and we can only hope to compare in our life. So why is Go different? Is anyone familiar with Go here? All right, we have a few people. So the main difference here is error passing. I think at this point we have to say that Sam was about to get fired because he spent like a week iterating on this code in a perfectionist attempt, and even though he had something working from the first day. This is like a friendly reminder that time is always a constraint when we're designing things. We're never designing in a bubble. And yeah. Going back to the subject at hand, error passing in Go. So it's a bit different than what you're used to in Python or Java, for example, or other languages where you simply throw an error. In Golang, you have to return the errors and then manually handle it. And this is like one of the decisions that were decided in a very dictatorship manner, but I think a lot of things require that kind of decision making. And it makes Go a bit special. It's not the only language to do this, but it's well known for it. And so doing method chaining here, where you're returning errors, is a bit weird, because now you need to handle the error somehow. And if you want to find a way around this, it's going to always come with downsides. Like you're not going to be able to find a clean way around this without sacrificing something big in terms of readability, in terms of complexity, in terms of hiding away things from the user and adding magic to the thing you're designing. And so because of this, because the designers of Go didn't want to go down that route, they decided that functional options was a better design there, because it doesn't have to chain methods. And I'm linking an article at the end, by the way, to a more in-depth article about why you should avoid method chaining and Go specifically. So if you're interested in it, you can check that out. And this is basically, the TLDR of why method chaining is not as useful in Go. But in Python, we don't have this problem. In Python, we can simply raise errors. And that allows us to have much simpler designs. So this was also interesting to see where the same design pattern did not translate as well across languages, not because it wasn't buildable in that language, but because the language is different, and that brought in a tiny constraint that completely changed the face of our design. So, to sum things up, I'm going to quickly show you a side-by-side comparison of how our code evolved. And in a moment, we'll have some time for questions, so maybe start thinking about those and putting them in Slido. We started off with simple requirements, and we created an equally simple design. It was just a function call with a couple of parameters. And this was great. It wasn't complex, it was simple, and any more, and it would have been bad, actually. And then our requirements evolved, and we had to support many more options. So we tried extending the function first before trying out other designs, but that turned out to be quite bad. But in that exploration, we found what needed improvement, and that allowed us to propose a better design. Even though it didn't fix everything, it was still an improvement along some metrics that we had in mind. So it was kind of necessary to start with extension. And then we came across config classes, which improved things a little. The validation was cleaner, and the solution was more reusable, but the docs were still average. And then inspiration struck. We wanted to borrow a concept from Golang. And so functional options seemed to perform much better on all the metrics. But there was still something about them that didn't feel right in Python. And when we explored it better, it did seem to be more complicated than necessary. And thankfully, we knew JavaScript, which allowed us to find an even better design. And that was the builder and chain pattern, which is very well known in Python, but not standardized as functional options are in Go. I feel like Python is a bit more Wild West still in terms of standards. So this offered us the benefits of functional options, but it was more familiar in the context of Python. And it naturally led us to store the builder state inside the class, which led us to builder and chain. So at the end of the day, combining experience from these different domains gave us a bunch of different lenses through which to see our design and improve it. And so I think the more you explore and be curious, the more you'll be able to gain tools that will help you design better things. And I think we should also try to avoid scythes in favor of lawnmowers, even though it probably feels epic to wield a scythe sometimes. And these are some sources for the talk. Rob Pike was one of the people working on Unix and one of the creators of Go, and he was the first person to talk about this publicly. And then Dave Cheney made it a bit more common. John Calhoun talked about method chaining in Go, and he's also a very popular figure in Go education. And then I also wrote a blog post covering this when I tried it out at some point a few years ago. And that eventually became this talk. And here you can find a few links to my GitHub profile and all these projects, as well as some blogs and videos I've made. And I'll be around till the end of the day. Thankfully, you know, I'm a bit shy to be approaching others, so here's an official invitation in case you have something to talk about. And thanks for your attention, and I hope you have a nice rest of your day. Take your time.
Okay, so we'll move ahead with the questions. So we have got two. You guys can add your questions on the Slido. So first question for you is there a reason to use camel case in static methods of option class?
No, I think it's not very Pythonic, but it is more fitting artistically, let's say, because it's coming from Go, where camel case is used there. So in my actual code, I wouldn't use camel case here. Good spot.
Okay, so next question. Is there a way to use functional options while also leveraging pedantic powerful validators?
I mean, you could use pedantic validation on its own, but yeah, I think builder and chain is already much better. So I wouldn't use functional options in Python in case this wasn't clear from the talk. Don't use this. Builder and chain is much simpler, much more Pythonic, but it was an interesting exploration as to why we shouldn't use this. I wouldn't also use pedantic validators in a builder and chain function, because that would be a bit hard. Like you might incur a lot of extra costs constructing pedantic models to perform the validation. You could hook into the internal pedantic validators and use those straight away, but yeah, a bit sketchy.
Okay, so if anyone has questions from the crowd, they can come or they can add it on Slido because we are over here. Does anyone has any questions? Okay, so a round of applause for the speaker.
Thank you. You guys made it through the last talk of the day. One more keynote and we're done.
she'll be talking about the data doesn't lie, but it can mislead. How to ensure integrity of your machine learning application. So I'll just let her take over. Thank you.
Thanks. Thanks for the introduction. Is the mic working okay? Not too loud? Okay, perfect. Stop me if anything goes wrong. Really happy to be here, and thank you all. Kudos for making it to the last slide of 3 days of a full conference. It's great to see all of you here. So let me just quickly introduce myself so that you know who is up here talking to you. So my name is Sophie van Landegem, and I sort of have two lives in the Python community. On the one hand, I'm an open source contributor, and on GitHub I have this handle which is unpronounceable, which is called SVinlandig. It was a bit of a joke between me and a friend back at uni, and I'm stuck with this unpronounceable handle for the rest of my career, but that's fine. So you might have seen me on repos, Python repositories such as Spacey, that I helped maintain for several years, as well as more currently, I've been involved with the maintenance of FastAPI and Typer, which some of you might know as well. So that's sort of one part of my career. The other part, some other days of the week, I am also a freelance NLP consultant in my one-woman company, Oxycoded. So in this capacity, I am sort of, the business analyst, the data scientist, and the machine learning programmer all at once, where I try to incorporate open source tools from the Python ecosystem, try to use open weight models and these kind of things, and try to create value for business, really. So it's in this last capacity with the sort of consultant hat on that I want to talk to you about data in machine learning projects. So let's just go through a sample, an example project where we want to create a portal with all Formula One news. So basically we have a client that is interested in collecting all of this Formula One news. Why? Because maybe not all people want to read their news or their summaries from an LLM, and they actually want to go and read the original story behind it. So we want to collect the actual stories that were published in different journals and so on. And we'll see here some of the main actors in the Formula One landscape. I'm not sure whether there's other Formula One fans out here. The whole talk will be Formula One, so I apologize if nobody else cares. I think it's pretty cool. So what we want to do on this website basically is we want to extract facts from the articles and then be able to link those facts to the original article. So in this particular case, last week, if anybody saw the race in Monaco, which is also always like a legendary circuit to run on. So last Sunday, Lando Norris won the race in Monaco. So when we know that fact, we also want to be able to provide the users with a link out to an actual news article that explains more of the details, what happened during that race, what are the consequences in the championship, and so on and so forth. As you can see, if you're not watching Formula One right now because you think it's boring, it's actually really exciting because there's basically a three-way contendership for the title. Verstappen is being challenged by both McLaren boys, Piastri and Norris, so I highly recommend watching. It's going to be an interesting year. So let's say that we have this, we have this requirement that we want to link these facts to given news articles, right? Okay, we've gone ahead and implemented some of this, and then we will have to go and watch the data. So this is always sort of a pet peeve of mine, is go and look at your data and see what is happening there. So this is an example fact that we extracted from last year. Let's say in 2024, at the end of July, there was a race in Spa. Spa is a circuit in Belgium. I am from Belgium, this is not a coincidence. So the race in Spa was won by George Russell. This fact was extracted by our system because of all of the sort of pieces of evidence that you see on the slide. We see an article where it reads about how Russell was able to hold off Hamilton for a stunning win in Belgium. We see a podium where Russell is clearly very happy, and Hamilton, and I think this is Piastri, is quite unhappy. So, many sort of pieces of evidence that showcase that indeed Russell won this Formula One Grand Prix at the time. So let's just do a quick sanity check. At this point in time, our system is extracting facts, is linking it to articles. What do you all say? Does this look like this fact is extracted correctly? Knowing that Spa is the Belgian Grand Prix? Yes? Hands up for yes? Well, not so many. Not so many are certain. Who thinks that this fact was not extracted correctly, or this is not a correct fact? No, but one person. Are you a Formula One fan? No, just sort of random guessing here. Okay, that's fair. So this fact was indeed extracted correctly from the given sources that we have here. But Russell did not win the Spa Grand Prix in Belgium. I guess some of you saw this coming, right? So you didn't dare to answer. You saw the trick question coming up. So what happened in Belgium is that Russell actually raced a brilliant race. He managed to pull off a one-stopper, so he only went to the pits once. And then he basically was able to, because of the pit strategy, was able to overtake many people and claimed victory at the end of the race. But Formula One is a heavily regulated sport, and at the end they also do like weight checks. Don't ask me about all of the details, but it turned out that at the end of the race, Russell had to be disqualified because he was underweight. He had lost a lot of weight because he was sweating so much in the car, but also his tires basically wore down significantly because he kept running on the same tires for a very long stint. So 2 hours after the race, they go and disqualify Russell and give the title to Hamilton. So then, of course, the newspapers do their thing and publish an update and say, well, actually, it was Hamilton who won it because Russell was disqualified. So that's an interesting point. If you look at just the NLP sort of side of things, if you give the natural language processing algorithm, if you give it just these two input texts, then, I think the NLP is very correct in saying that there's two different facts to be extracted here. It's not making a mistake saying that Russell actually won that Grand Prix because this is what the sentence says. And the NLP is supposed to, analyze the grammar and analyze the semantics of the sentence and extract the fact correctly like it did. But in this particular case, we'll need to have some filtering in place so that we can actually deduce, well, who was in the end the correct winner of this race. And you might tell me, well, Sophie, that really isn't all that interesting, because, well, sure, okay, first we had a winner, then he was disqualified. The NLP should really be able to see the different timestamps, for instance, on the articles and sort of go with that and understand that this was an update to the result. I agree with you, but it's not always that easy. So recently, and if there's not a lot of Formula One fans in the room, then you might not know this series either, but then I would highly recommend watching this because it might get you into Formula One. So there's this Netflix series called Drive to Survive, and what it does is after each season of Formula One has ended, they basically, let's call it a documentary. They created a documentary sort of summarizing all of the races, all of what happened in last year's of Formula One season. And it's not just a documentary. There's also quite some drama going on, and they highlight the personal narratives a little bit as well. So it's entertaining to watch. So this year, they talk about last year's Formula One racing, and there was this, I think it was the third episode of the season that's called Looking Out for Number One. And the narrative here is about George Russell. So George Russell, who runs for Mercedes, and he is basically stepping into a leadership role at Mercedes. Why? Because Hamilton is leaving Mercedes, as some of you might know. He was leaving Mercedes to go to Ferrari, the Italian team, and he did just that in January 2025. So the whole episode is about how George Russell is stepping into this leadership role, how he drove a brilliant race at Spa, which is all true, and then he's on the podium, which is all true. And that's where the episode ends. They don't actually mention that he was disqualified at the end of it. So it was very confusing to me when I was watching this episode, knowing that in the end, there was this disqualification, which is not a minor detail. It's actually something that happened and which was quite important. And they don't even mention it. So this was published months after the fact. And, well, like somebody on Reddit, I think, accurately puts it, it's almost like they pretended George won Spa, which is a bit weird, right? And why am I saying that? It's because this Drive to Survive sort of series is what I would call is a very authoritative resource. If you would be parsing information from there, if you would be looking at that video as a non-domain expert, you would be saying, well, that is probably what happened. Russell won it. That seems to be the case. So it's very important to sort of making sure that you watch your data closely. And I think the main takeaway from this is that what you really need is have a domain expert on board. Somebody who knows the data, who knows the domain, who knows what happened, and who won't easily be fooled by, some random narrative that some producer for a Netflix series has created. So have that domain expert on board. Whenever I am working on a consulting project and there's a domain expert, I try to treasure them because they always have little nuts and pieces of information that will come in handy throughout the project. So nourish these people. Let's get back to our portal. Let's say that we have all of these articles, we have all of these facts extracted, and now we also want to provide a link out to Wikipedia. So what I mean by this is throughout the articles, when you're reading them as a user, you also want to get some background information. So who is this Hamilton guy? What is this Mercedes team about? And on the English Wikipedia, for instance, let's take English as an example, there's a lot of information about that. So we want to be able to link out to those articles. What that would look like very specifically is, for instance, here, we have the sentence that we now all know to be true. Hamilton won the Belgian Grand Prix in Spa in 2024. In case you hadn't noticed, I'm a huge Hamilton fan, so this is kind of where this is coming from. I kind of wanted to set the record straight here. I think I've done that. So in this sentence, Hamilton won the Belgian Grand Prix in Spa in 2024. Let's say there's two entities that we're interested in, Hamilton, and then the Belgian Grand Prix. So these are two entities that we can provide Wikipedia pages for. So in an ideal sort of situation, we would link Hamilton to its page on Wikipedia, Lewis Hamilton, or Sir Lewis Carl Davidson Hamilton. He was born in an awesome year as well, 1985. And then the fact that he won the Belgian Grand Prix. So there's another article about this Grand Prix. So that is kind of what we want to do. This might seem straightforward to you, but it's actually a quite difficult task because there's a lot of ambiguity involved. You need to be able to understand the context of the sentences to understand which exact article it is that we need to link to. And I'll show some examples in the rest of the presentation. So we wanted to go and build this entity linking model. And to do that, it's actually quite easy with Wikipedia. They provide all of this training data for free. And this is work that we did several years ago. So you might notice that it's still a little sort of, we were still using some sort of traditional supervised learning methods, but the learning will stand as what I want to say. So in this case, the training data that we can harvest is just for free available on Wikipedia. Because if you look at that first sentence, so Lewis Hamilton is a racing driver for Ferrari. Look at the words Ferrari. They are just sort of mentioned as Ferrari in the sentence. But if you go and look at the actual underlying, let's say, source code for the Wikipedia page, we see their links with these brackets is that they link out to an article called Scuderia Ferrari. Because obviously Ferrari is a auto manufacturer, but in this particular context, we mean Ferrari, the racing team, right? Clearly the two are related. Audio still good? Yep. Okay. So clearly the two are related, but we want to link out to the actual Ferrari racing team. So by harvesting these links, and you can just download the whole of Wikipedia and get all of these links, by harvesting these links, we can teach the model that in this particular kind of context, if we see Ferrari, then we mean the racing team. In another context, we might mean the auto manufacturer. And this is how we train a model to look at the context and then find us the correct page to ambiguate to. And then that will be our link out on our portal. So we've gone ahead and built an entity linker model. Like I said, this is a little outdated. This is a few years old, and I won't go into many details either. This is a whole separate talk. I'm happy to talk about this at some other time or offline. But basically what we did is we created a large sort of feed-forward network where we look at the mention in text. So take the sort of sentence embedding of the mention, let's say Hamilton, and then also an entity candidate. So the candidate in this case is the Wikipedia page. So we add the textual mention and the Wikipedia page. We throw it in a feed-forward network. And what sort of comes out is a probability whether or not in that particular context that is the right Wikipedia page to link to. And then we'll basically train on this because we have all of that gold standard data from our interwiki links that we harvested. So we trained this model. Cool. And we got 79% F-score. That's good, right? We were happy with that. 79% is a decent enough high number, we think. I guess it's pretty good, right? 79%? Not sure. So let me tell you how most clients and users think about performance, because I don't think a lot of people in the data science world think like this, but this is important to understand when you're communicating performance numbers to your business clients. What they usually think is, well, 100% clearly is the best model ever, and everything is entirely correct that the model predicts. And 50% is like the worst model, because 50% is like random guessing, right? No. A random baseline is almost never 50%. I mean, maybe if you're throwing some dice and looking whether it's an odd number or not, then it's 50%, but usually in real-life world cases, this is not the case. In fact, for our entity linking task, if you go and look at the English Wikipedia, there's 7 million articles on it. So if you pick one at random, will have this number on the slides, 0.0014%. Let's just call it 0%. If you just pick a random one, we'll have 0% accuracy. And at this point, it doesn't really matter whether it's F-score or precision or recall, it'll be 0%. And in fact, our upper bound wasn't 100% either. We had some efficiency requirements in this particular project, which meant that we couldn't keep all of the whole database of Wikipedia concepts, again, 7 million, so quite big. So we only kept 14% of it. Of course, we tried to be pretty clever about it, and we tried to keep only the concepts that are often mentioned in sentences, concepts that are really relevant, because Wikipedia also has a lot of niche concepts and so on. So when we keep those 14% of all the Wikipedia concepts, then we calculated that, or let's say an Oracle disambiguation step that would always pick the right one, if it is there in that database, then that Oracle would obtain 84% F-score. So that, at the time, was a reasonable trade-off for us, keeping only 14%, still being able to disambiguate 84% of our cases in our data set. But it meant that we've significantly lowered the upper barrier, basically. So the modeling now targets a 0 to 84% range. Cool, that's interesting information because, in a range of 0 to 84%, 79% is really good, right? Michael on the slide is unsure, and I think by now you see me coming, that we're still a little bit unsure about this. Of course, I've done this on purpose. Why? Is because I want to say that you never really know what this 1% number means unless you put it into perspective. So how shall we do that? What we really need to do here is to develop some simple baselines so that we can better understand the complexity and the data challenges of your project. And I will run you through doing exactly that, just to give you sort of a feel on how that looks like and what that would feel like in your own project as well. So in our case, obviously, we won't be assigning the mention Hamilton in a sentence to any random page on Wikipedia. We're not that stupid, right? We're not just going to assign a random one out of the 7 million ones. We could do something clever. For instance, we can obtain a list of Hamilton candidates by doing either some very simple lexical search or doing some more complicated fuzzy search, whatever it is that you want to do. Depends a little bit, again, on the precision recall trade-off that you want to hit. But let's say that we just look at things that are called Hamilton. And for instance, there is a musical. There is a Duke of Hamilton who lived in the 17th century. Of course, there's our race driver. And then there's also an Alexander Hamilton, who was an American military officer in the 18th century. Never heard of him, but he's a valid Hamilton candidate. We might be talking about him in our sentence. Who knows? If we do this for all of the instances in our data set, so all of the mentions that we have that we want to disambiguate, we create this, let's say, plausible list of candidates just by doing a lexical search. And then we pick a random one from this list. Then we actually obtain 54% in F-score. This is pretty clever because we've just been doing a very silly thing, just something very stupid. And I'm always a fan of doing stupid things first because it helps you understand what your data looks like. It helps you understand how far you can get even without doing any machine learning, any fancy stuff at all. So 54% in F-score we obtained. That's cool, but we can create an even stronger baseline, I'm sure. Let me introduce you to the concept of prior probabilities. So a prior probability is kind of a measure on how often a mention is linked to a certain concept. So for instance, if we have a sentence and we have no notion of the rest of the context, but we just see Hamilton, all of these cases on Wikipedia, let's say that 75% of them will eventually link to our race driver. It's just because this word or this person is being mentioned more often than other Hamiltons, like Hamilton the musical. I don't know whether anybody knows Hamilton the musical. I'd be happy to hear whether it's a good one. And then maybe 7% of all these Hamilton cases on Wikipedia point to the 18th military officer, 18th century military officer, and so on. Then again, if you have the actual string Lewis Hamilton on Wikipedia, you might imagine, of course, that these cases will much more likely be referring to our F1 race driver, so maybe something like 99%. And if it's Alexander Hamilton, of course, the prior probability that this is referring to the 18th century military officer is also pretty high. So I hope that this sort of gives you an intuition on what prior probability means. You can sort of compare it as well to when I say Obama without any other context. Most people will be thinking about the former US president, even if they haven't heard of any other of the context. But this is sort of the prior probability because that term most often refers to that president. What we can do with these prior probabilities is just sort of extrapolate them to the extreme and just say that whenever we see a Hamilton, whatever the context is, we'll just say that it's the F1 race driver, 100%, because the prior probability was 75%, 75% is majority. We'll just call it 100%, call it a prediction, and call it a day. And then for Lewis Hamilton, the same, and Alexander Hamilton will be the military officer. This is just very black and white thinking, and this means that we don't have to look at any context at all. The funny thing is that this prior probability baseline actually obtains, in our case, on the data that we had at the time, 78.2% in F-score. And this is super interesting because, again, we haven't done any machine learning, we haven't tried to analyze the context at all, and it shows you something about how skewed our data is. It shows you that a lot of the entities are, so prevalent that they sort of swamp the data set. And if you just sort of, predict the most likely thing without thinking more than that, you will actually get 78.2%. So this is really good to know. And taking it back to the question that we had before, so our machine learning model on the one hand is supposed to disambiguate based on context. It obtains 79%. Our relatively simple, if not to say quite stupid, baseline obtains 78.2%. So is this a good model? Yeah, maybe not so. Or maybe the data is flawed. And so this is exactly the point that I want to make. By developing these baselines, you will get an idea on how difficult your challenge is and what the context is for interpreting your performance measures. So this is what I said. The baselines put your machine learning's performance measures in the right perspective. Let's go back, because we're not done. Let's actually revisit that upper bound again. Is it really 100% if we have no memory or efficiency requirements? So let's say that we didn't have to prune that database and we did keep all of the 7 million concepts. Would we still be obtaining 100% precision? Well, and this is a little bit sort of the philosophical part of the talk. What does correctness even mean? 100% precision means that every disambiguation is correct. But what is correct? And let's not stay philosophical too long. I think it's a Saturday night, it's late, so let's make it a little bit more concrete, I think. We have this favorite sentence of mine, which reads, Hamilton won the Belgian Grand Prix in Spa in 2024. Now let's look at the entity Spa. And we're still wanting to disambiguate this to the right Wikipedia page. So I present here for you two sort of candidates, two plausible Wikipedia pages. On the left, we see the circuit of Spa-Francorchamps. So this is the circuit, the racing circuit that lies in Spa. And it's often also just sort of informally referred to as Spa. And then, of course, there is Spa, which is the city of Wallonia, and which is where the race circuit clearly gets its name from. So let's try and do a little bit of live annotation here in the room. And let's say, suppose that you are the annotator or even the user of this system. You're reading this sentence, and you want to get a link out on the word Spa to a Wikipedia page. Which of the two would you prefer? Would you want it to link out to the circuit or to the city? So let's do it by hands. Maybe the circuit. Who wants this to link to the circuit? Quite a few people. Who thinks, or who would prefer this to link to the city of Wallonia? Also a few people, also quite a few people, but significantly less people. So I think in this case, there's really no wrong answer. If you think in sort of grammatical way of parsing the sentence, the Belgian Grand Prix is in Spa, in the city of Spa. That's where its location is. But you can also say sort of semantically, well, it was on the circuit of Spa that he won it, so maybe the left one. So I think both are sort of valid explanations. So I think, I've never had the chance to do this kind of thing in a large audience, so let's do a few more. I have two more. So let's go through this one. Societies in the ancient civilizations of Greece and Rome preferred small families. We have two options here. Again, on the left, we have an article that is talking about the ancient Greece, basically a Mediterranean civilization in the Greek Dark Ages, so sort of ancient Greece. And then on the right, there's the current country, Greece, as we all know it, which is a current country in Southeast Europe. So again, hands up for who thinks we should disambiguate this to ancient Greece. Okay, that seems quite a lot. And who thinks it should be current Greece, current country of Greece? Okay, I'm with you guys. I also think that this should be current country of Greece. Why? I think because I interpret this in a sort of, again, grammatical way. Ancient civilizations of Greece, of the current country Greece, is how I read the sentence. But it's, as you see, it's quite sort of a personal preference. And on Wikipedia, you will always often find that they will go ahead and link the left one because it's sort of more informative. If you want to click through and read about the specific topic that you're reading in this sentence, it probably makes more sense to go ahead and read more about the ancient Greece, right? Cool. One more. Because this one, well, I had a bit of a discussion about this one, so I want to see what your opinion is. So full metro systems are in operation in Paris, Lyon, and Marseille. So on the left, we have the option of linking out to an article that is a specific article about the Marseille metro. There's a whole article about this on Wikipedia. And on the right, there's the actual article of the city of Marseille. So who wants to disambiguate it to the left one, the Marseille metro article? Not so many people. And who would want to link it to the Marseille city? More people. Okay, so this time it feels like you're going with the grammar, sort of grammatical explanation. The metro system is in Marseille. So Marseille is the city of Marseille. And maybe we want to know more about that city because we have 3 cities in this list and we want to know more about Marseille. It's a nice city to visit as well. So it's interesting to see, and this is what I wanted to do and see this sort of ambiguity in the room actually, because that's kind of my point. Often when you have multiple annotators labeling or curating the same data sample, they don't always agree. So this is where that sort of philosophical question comes in of what is correctness. And you can measure this by looking at inter-annotator agreements or IAA, which basically will tell you how often annotators agree if they label the same data sample. If you have high inter-annotator agreement, you're really good because it means that the annotators mostly agree, the goal data is reliable and robust, and that's really good. It's a good sign for your project. If the inter-annotator agreement is low and your annotators disagree, that might be because of various reasons. Maybe the data is confusing, dogs versus muffins. Maybe the label scheme is ambiguous. Maybe your annotators are just a bit confused about the label scheme, and we'll see a few examples of that later on as well. Or maybe the NLP task is too complex, and this is something that you definitely shouldn't rule out. So basically, whenever you run into this low IAA stuff, go ahead and look at your data and critically think about your challenge and your data and what it is that you're doing and why this is ambiguous. So let me show you an example of this. Let's go back to our portal. And let's assume that we have all of these newspapers coming in, but we really only want to show Formula One news, right? But we have all of these articles coming in and we need to decide whether or not they're related to Formula One. So this is kind of, this is taken from an actual project that I did with a client 2 years ago. I just changed the domain a little bit to match the Formula One team here. But so what the client did was give me an ontology, sort of a label scheme, as you can see on the left. And then we had all of their articles that we needed to label. And the requirement was that we should put exactly one label to each article in these newspapers, right? So we did that, we had some annotations, and then we plotted the inter-annotator agreement of the labels. Again, this is a little fabricated, but it looked more complicated even in the project. But let me walk you through the slide and show you what is on here. So basically, there's a bit of a color scheme going on, going from 0 in blue to 1 in yellow. And what you would expect is that if all of the annotators would constantly agree on every data sample, then you would just see ones on the diagonal. You would just see yellow ones on the diagonal and zeros everywhere else. But what we see here is that, for instance, between US politics and global politics, we don't see a 0, which means that there are some articles where maybe one annotator annotated it with US politics and the other annotated it with global politics. So what it really gives you is some confusion between these two labels. And I guess between global politics and US politics, that is something that we can all kind of understand. Maybe there was something happening. I couldn't really imagine what could be happening in the US that could have sort of a global effect. But let's say that there was something confusing going on there, and the annotators didn't quite know how to label it. Could happen. In these kind of cases, you can definitely consider merging labels if humans can't reliably distinguish them. I'm not saying that this is particularly the case for US politics and global politics, but there might be other labels where the distinction might not really be relevant in the end. So we've seen, I've been involved in projects where annotators just spend a lot of time trying to distinguish between labels that at the end, at the end of the sort of downstream business case, it doesn't really matter which of the two labels was applied. And in our case, this is true as well. We're only caring about Formula One. I don't care about politics at this point. I think that's a good stance to be in at this point in time. So let me just watch Formula One and be happy here. Let's just call it politics and be done with it. But there's a few other cases in this sort of confusion matrix that are more interesting. So for instance, there was some overlap between US politics and Formula One. That's weird, right? You would certainly think that your annotators are clever enough to see the difference between Formula One and US politics. Whenever that happens, and these kind of cases happen often in projects, just go and look at the data. The data will tell you what is going on. And you will see something like this. There's an article here about how the founder of the Haas team, Gene Haas, funny guy, he owns the Haas F1 team, and he was basically saying that it's really difficult to decide where to invest and how to go, about making business decisions in the Formula One racing domain because of something that was happening in the US, something about international tariffs. I haven't followed. I was watching the Formula One races. I'm not sure what happened there. But you can imagine how one annotator says, well, this is clearly about Formula One, right? Formula One is impacted. It's even one of the founders of the teams is there. And then another annotator is saying, well, this is clearly US politics, right? So there was a lot of confusion. When we saw this data, I was basically able to say to the client, well, you see, this is why we should put more than one label on one article, right? That seems like an obvious thing to do, but the client was very adamant in the beginning of the project that we should label each article with exactly one label. And only when you have sort of start collecting the data, start collecting the ambiguity, and can show some cases to the client where that actually doesn't make sense or where you run into some sort of gray area, then you can convince them to maybe reframe their NLP task. And that is exactly what we often see happens. I think this is something that maybe in the beginning of your career, you don't realize as much, but often enough, if there's a client coming to you with a specific question, they have a specific task that they want you to do, you can often reframe it. You have to look at the data and understand what is like the best approach for this particular data and this particular challenge. So don't be afraid to do that. Then the last sort of case that I wanted to explain on this confusion matrix, it's not really a confusion matrix, but for lack of a better word, is something going on in the sports category. And to understand what the problem is here, we basically have to revise the ontology again. What happened here is that on the root category, we have a sports category that has subdivisions in football and Formula One, makes sense. Then we have politics, and then another root category is leisure. And within leisure, there's another subcategory called sports. And so some of the annotators just glanced over the ontology and put sports or the other sports, so basically one sport and 3B sports, and this was where some of that confusion happened. And you might be saying, well, Sophie, this is a little silly example, but this is, I promise you, it was worse than this on the actual data. There were names that were sort of duplicated all through the ontology, so that really needed to be cleaned up. And remember when I talked to you about this domain expert before, and I really still stand by that statement, it's very important to talk to the domain expert, have them explain why the ontology is like this, because they often have a good reason, but then still try and sort of guide them towards a revision of the label scheme that makes more sense, and that will introduce less ambiguity in your data overall. Okay, let me just take a quick sip. So that's all fine and well, and if you have multiple annotators, you're a very lucky girl or guy. But I can kind of hear many of you thinking, well, that's fine, but I don't have multiple annotators. Like, they are costly, that's human labor. Maybe we don't annotate all of that much data anyway. So what do I do? What do I do if I don't have these multiple annotators and I can't really create these confusion matrix and so on and so forth? Well, the other thing you can do is you can analyze discrepancies between your model's predictions and the gold standard label. So this is kind of sort of a little game between a model and your human annotator, if you have one human annotator, which in the worst case can be you. So this is what happened in the original entity linking project. We have here a certain Agnès Maria. I'd never heard of her before, but she was apparently a queen of France, and she died in 1201. And so the gold annotation on Wikipedia at the time when I was harvesting this data was that if we read the sentence, she was a queen of France, the gold annotation linked this to the current country, France, right? That makes sense in a way, but then on the right-hand side you see the prediction of the model, where the model actually found this Wikipedia page that I didn't know existed about a certain kingdom of France in the Middle Ages. And if you go and read the details of this, the timing is exactly correct. So the 1201 time period fits into this article that the model predicted. And it's times like these where I get a little emotional and be like, well, model, that's really well done. You know, you've gone and looked at the whole of Wikipedia and found this very specific article about France in 1201. Nice. But at the same time, the gold annotation is the current country. So this is a incorrect prediction if we measure it as such, right? So, and this was also one of the problems behind that 79% performance number, is that there was a lot of sort of issues with the data set, and that is why I wanted to do this live annotation with you earlier to show you what that kind of ambiguity really looks like and feels like. So here you can really question, is this an incorrect prediction? Or maybe the label is wrong. Maybe the original, writer on Wikipedia should have linked to this Kingdom of France article. Maybe they didn't know about this article, because it's very, very frequently you would just link France to the current country, France. That's a sort of understandably action to take. The other thing you could say is, well, maybe both answers can be correct, right? And this is something that I've come to sort of realize throughout my career. I think in the beginning, when I was doing machine learning and doing performance evaluations, I was very sort of black and white. Something is either a false positive or a true positive. It's either correct or incorrect. And I think I've stepped back from that a little bit, and I think that makes sense to do. So this is a chart that I showed, that I basically sent to a client only 2 months ago, where I was analyzing some data from them, and I was doing the evaluation. And I basically said to them, okay, so I've found a lot of cases that are correct with the model that we built. So these are the blue ones, the largest portion. And there's definitely some that are clearly incorrect, the orange ones. And then there's some cases where I'm saying, the prediction and the gold label are not the same, but they are related. It's kind of like this France versus the old France, or Greece versus the ancient Greece, or Lyon versus its metro system. They are related, and it will really depend on the downstream usage of your data and of this application, whether or not you will be happy with those related cases. And if it really matters whether which of the two, in the end, we end up resolving to, then we should go and have a look at this data, maybe make some better annotation guidelines and so on, make sure that this data is more firm. So in the end, I basically just communicated the precision is between 87 and 96%. I think that's okay. The other thing that you should do, I think this is a really cool trick to do, if you have a supervised model, if anybody still does that, I think there's still plenty of use cases where you can use small supervised models, is basically apply them to their own training data set and see which ones they predicted wrongly. Because what you will find are structural data errors, and I want to show you an example of this. It's really a neat trick, and I don't think a lot of people are doing it. So let's say that we have a manually annotated training data set where we're annotating the names of circuits, so basically Grand Prix circuits. So in the first sentence, to kick off 2025, Dutch Grand Prix weekend in Zandvoort. Zandvoort is the racing circuit in the Netherlands. So here, Dutch Grand Prix is the entity that we're extracting, that we're labeling as being the circuit name. In the second sentence, we have Gasly Lemons, a quite sad Monaco Grand Prix crash last week, unfortunately. So here, Monaco is the name of the circuit and is being annotated as such. Of course, there's many, many more examples like this. Then when we train a supervised model on this kind of data and apply it back on its same training data, and this works especially well with small models, because they are supposed to generalize, they cannot memorize every single entity in the data set. They will try and sort of define internally generic rules that will help them make predictions. So in this case, the model predicted that Monaco GP is the entity instead of just Monaco, as we saw in the training data set. And you can easily find these discrepancies just by comparing. And so what happens here, we saw several of these cases, so we dug into this data more. And what we noticed is that the words Grand Prix were sort of half of the time annotated as part of the entity, and the other half of the time was outside of the boundary of the entity. So as you can see in the first two examples, Grand Prix is annotated as part of the entity, and in the second example it isn't. And then the model got confused, rightly so. Again, this is where I sympathize with the model, and I'm like, yeah, you're right, this was just confusing to you, and you've done your best. So this is actually not a bad prediction. But it tells you should go back and probably re-annotate your data, and when doing so, it really helps to write up annotation guidelines. So if you're ever lucky enough to work with like an annotation team, or at least one person, a domain expert who wants to annotate your data for you, make it very easy for them to be consistent in their predictions. They will do this annotation over several days, maybe several weeks, and they will have to make decisions that are sometimes in a gray area. So it really helps to give them specific examples, to be as clear as possible in specific instructions. For instance, in this case, we can decide that Grand Prix should be inside the entity annotation. You can also decide the other way around, whichever you want. But it's also nice to have these annotation guidelines because it will also help you to do some semi-automated checks on your data set once you've been able to define all of this. Finally, correctness, as we discussed it before, may also depend on the downstream usage of your results, and we've already hinted towards that a little bit. So when we go back to this example that we saw where Hamilton was winning in Spa, and Spa is either the circuit or the city in Wallonia, it doesn't really matter if we're not looking to link out to a Wikipedia page, but for instance, we just want to know Hamilton and the Belgian Grand Prix, and we just want to, extract the correct Grand Prix happening. So this was July 2024. If that is our end goal, then it probably doesn't really matter so much what the intermediate step is. We will probably arrive at the correct answer in the end anyway. And this is kind of what I mean by defining the right hill to climb. You have to understand what it is that in the end is necessary in the downstream application that your client is using, how they will be using this data and these results. And so by defining that right hill to climb on, you can set yourself a sort of correct evaluation framework that you can then start working towards. So defining the right hill to climb is really thinking about, is your data correct? Is it consistent? Is it robust? Is the test data representative of the real-world data? Very important and something that is often overlooked, especially by clients. And does your evaluation framework really capture the value of your algorithm in production? Have you talked to the domain experts? Have you talked to the people who will be integrating this data and these results into their downstream frameworks? And do you really understand how those results will make a difference? And does your evaluation capture that value? Only after you've been able to define that right hill to climb, then you can get to the fun stuff. And those are 5 more presentations, unfortunately not for today. Then we can get into the algorithm development, do the model training, the LLM fine-tuning, and so on and so forth. So let's wrap things up with a practical checklist, because I'm sure after 3 days of PyCon, you're all very enthusiastic to go back to your computer and start implementing projects. And if you're working on machine learning or natural language processing projects, I just want you to have sort of a checklist in your head that you can use to make sure that you're making the most out of your work. So first and foremost, when you're looking into a machine learning project and you're doing data annotation, make sure that your label scheme is consistent and unambiguous. And I would even say, even if you're not doing data annotation, because most projects will have a label scheme. Even if you're working with LLMs, whatever you're doing, you will have some sort of schema that your data will need to be put into. Make sure it's consistent and unambiguous. If you are doing data annotation, draft clear annotation guidelines. It takes a bit of work, but it will pay back in ensuring that the data is consistent. If you have multiple annotators, measure this inter-annotator agreement, IAA. And if it is low, you have to go back. You have to go back and either reframe your task, reframe your guidelines, think about your data critically and understand why the IAA is low. Talk to your annotators, understand why things are ambiguous and why they have made certain decisions. Do this sort of exercise that we did here in the room and talk to the different people and try and understand why somebody was linking it to the ancient Greece and why somebody to the current Greece. And I think another important point is to model that uncertainty in your annotation workflow. When annotators are annotating, don't just give them black and white examples. Also give them the option to say, I don't know, or this example is unclear, or maybe the data was parsed wrongly, because otherwise, if you force them into a decision, they will click something and they will make a decision, but your data will just simply be, it will not be good. When you're doing performance evaluation, think about that 79% that we had and where we were unclear whether this is actually good or not, and develop simple baselines to put performance into perspective. Like I said, I'm always a huge fan of doing the simple thing first. Just try and do something stupid in the beginning. Maybe doesn't even include machine learning or an LLM. Just have some statistics, do some statistics on your data and see what you can come up with. Remember that prior baseline that we had that already had 78%. It told us a lot about our data. You can quantify realistic upper and lower performance bounds. It's not always 0%, it's not necessarily 50%, and it doesn't have to be 100% at the upper bound either. And then measure performance as part of the larger business process. And this really takes you to go and talk to the client and understand what it is, why they're using this data, and how this will be impactful. Then a few sort of tricks that I like to use is identifying structural data errors by predicting the training data. This is specifically important if you're creating supervised models. And then, of course, that's just a little trick, running it on the training data. That's not how you should measure performance, clearly, but have some truly unseen data where you measure the realistic performance of your model on actual unseen data. And then finally, make sure that you're climbing the right hill. So I know that this was a lot, and I probably talked a bit too fast, so I might have won us some time to get back to the conference. But if there's only one thing that you remember out of this talk, it's that Hamilton won the Belgium 24 Grand Prix, not Russell. Thank you.
Okay, so that was lovely, Sophie. Thank you so much. So we'll take on the questions now. So first question for you is, how important is time as a dimension in your inferences? Do weightings depend in any way on recency? And would that have helped with Hamilton and Spa?
Yes, exactly. So that's a good question, and clearly it is very important. So when I was showing you the articles about first Russell winning it, I think this was at 4 p.m., and the same day at 6 p.m. It was Hamilton winning it. So clearly if you look at that timestamp, you will be able to make that distinction. But then months later comes this episode of Drive to Survive where they repeat the storyline that actually it was Russell who won it. So in this particular case, you might create some, or let's say Netflix has created some confusion by sort of distorting the timeline again. So it's not a magic bullet, is what I want to say. It's you definitely need to take that into account when doing the filtering, when doing the disambiguation, but not a magic bullet, unfortunately.
Okay, so next question is, was it surprising to you that 80% of data science is cleansing?
That 80% of data science is cleansing? Yeah. Surprising, when I came out of uni, yes, maybe. I don't think anybody has ever told us when I was at uni. I happen to kind of like that part of data science, so I like digging into the data. It's actually surprising to me how often data that you think, well, this will be fine, right? Like the client will give me that and I will be able to work with that. There's always a day of work of cleaning it. So one example that I had that didn't make it into the slides, but that is quite related, is when a client was giving me news articles, so very similar to what I was showing you here, and they said, well, it's a clean database of news articles. And so they give me these news articles where I don't know exactly how it goes, but there's clearly some broadcasting process going on. So I don't know, Reuters or something broadcasts an article, and then other journals take the same article, they change it ever so slightly, and then publish it again. So what you end up having is all of these artificial duplicates from all of these newspapers, that all of the sentences are almost the same. And then if you go and create a supervised model on that, it might be that half of these very same articles could be in your training and the other half in test. And if you hadn't noticed that, you'd actually creating a huge bias because of that. So yeah, looking into the data, cleaning it, it's always step one, and you need to continuously do it. But I happen to like it. Yeah.
So next question is, Do you kind of cross-check your model against commercial LLMs? How do they fare?
So it depends, right? So the models that I'm creating often have features or sort of, well, generic LLMs just are LLMs, they just output text. The projects that I typically work on are with sort of structured information. So this is classifying things, extracting information, and they don't typically come out of the box. You have a lot of models on Hugging Face. Sometimes there are models that are sort of doing similar things on Hugging Face that you can then try and compare with. But often enough, there are sort of custom tasks that need to be done. They're not like chatbots. Because I don't really work on generative AI, more of the extractive.
Okay, so moving on to the next question. Do you use libraries like CleanLab to automatically check label quality? If yes, what's your opinion on them?
It depends on the project. I don't know the specific library that has been named here, but I do apply several libraries. It depends on the project, what kind of data looks like, what the labels are, and then try and plot sort of characteristics of the data. So for me, this is part of, let's say, the first week of the project, where you just look through the data and throw some libraries at it. There's indeed several good libraries that find outliers, that find maybe mistakes in the data set. So there's definitely a whole suite of libraries to use there. That would be a separate talk.
Okay, so next question for you is, what is the take on the impact of LLM on NLP? So how would it change the way past projects were implemented?
So I didn't catch the impact of LLMs on?
So I will repeat the question. So what is your take on the impact of LLM on NLP? How would it change the way past projects were implemented?
I mean, clearly it's blown the whole field of NLP out of the water, right? LLMs, I think, have been huge, clearly. I've been doing NLP for almost 20 years, and the way that we're doing NLP now is just completely different than the way that we did it with before. That said, I do think that there's still cases where we can use, like I said, smaller supervised models. I don't think we need to throw an LLM at everything. I love experimenting with LLMs, but I also like sort of doing that trade-off and seeing if I use a lot less memory and a lot less GPU power with a small model, and how will that sort of compare to an LLM. Maybe the LLM gets 5% better in accuracy, but maybe that trade-off is something that the client is happy to sacrifice if they want like a real-time framework or something like that. So to me, it's another tool in the box, but it clearly has overtaken most of the NLP field. But I don't think that we should forget everything else. I still think that we have like a whole arsenal of tools to use.
Okay, so next question for you is, bias is a metric with a specific meaning in statistics and ML, and it is normally never zero in practical cases. It is used in a different way in common context. How do you teach your client/user about the difference?
Could you repeat it again? Okay, sorry.
Bias is a metric with a specific meaning in statistics and ML, and it is normally never zero in practical cases.
Right.
It is used in a different way in common context.
Right.
How do you teach your client/user about the difference?
Yeah, that's a good question. In general, this kind of concept, I would never try and explain the statistics behind it to clients, to most clients. Not because I think most clients are dumb, by far not. But what I think they are most interested in is the impact that bias has on their use case. So if there's bias in the data, and this is preventing us from creating a good model, for instance, then I would try and explain it this way, and I would try and sort of explain the impact that it has on the larger project. So it's more of sort of a domain-specific, use case-specific approach to it that I think makes more sense, and that more clients will be more interested in than sort of the theoretical framework of it, if that makes sense.
So I think we are done with, would anyone like to ask any questions? I will pass on the mic. Is anybody interested? No?
The QR code should also link out to LinkedIn, so always happy to connect or talk offline as well, if there's any questions.
Okay, so thank you so much. A big round of applause for Sophie, please.
Molto meglio. Sì, ma I don't see all the other. Where's Matteo, Patrick, Marco, Esther? Ah, suo figlio. No, I mean, that's an informal thing. Yeah. Pronto? Prova. What? Yes. Please stop sending me messages on Telegram because my phone is gonna be like, okay, I got rid of my smart.
Sì.
Okay, so unfortunately this edition
It's over, unfortunately.
Unfortunately, yeah. So we are absolutely improvising. We didn't test any of these slides or
All
we didn't
best things
sketch anything.
comes to an end.
Of course. So this is gonna be random. I don't remember neither the sequence of the slides that I just wrote a few minutes ago.
Oh, the words. You don't remember
What?
the words.
The who?
The words.
The words. Okay. That works. I mean, yeah, the mimic is much better. So thank you to everyone. And that's great. I mean, a lot of people here still after 3 days of conference. That's a great goal. And now I'm gonna give you some numbers regarding this 2025 edition. Matteo is gonna show you the numbers.
A few numbers. We had 40 different countries at PyCon Italia this year. Thank you so much. This was huge. It was a great result in terms of diversity, in terms of ideas, in terms of people warmth. Thank you. Of course, you have to work better to reach Italians.
No, that one is Ireland.
Ah, sorry.
Yeah. The last one is Italy. You know,
Yes.
that's, you know. Anyway, we had, as Esther said in the opening, we have over 1,000 people here, 1,004 to be precise.
1,012.
12?
We have counted each other.
All right. Other numbers now.
Yes.
So,
yes, again, a lot of people from outside Italy. Okay, you have to work better, but you are close.
yeah, I started thinking that this would be better as a donut chart, but then, I mean, I hate donut charts, so...
No, you can't handle that. Okay?
Yeah, we should have plotted some just numbers without any charts, actually, because it's just 2 numbers, but I love doing charts. So we had numbers, other numbers.
120 sessions around. Okay? Yeah, a lot of.
And what is, yeah. And of course, that one is one of the sessions. Of this year is Antonio Scuni.
Yeah.
Antonio Cuni's session. So thank you, Antonio, for being here again. It's like, I don't know, 20 years in a row so far?
30 years, 40 years.
We had 6 keynoters.
6 keynotes, thanks to our keynoters. It was a pleasure and an honor to have you here.
And we had 3 lightning talk sessions this year.
Best speech
It was
of the year.
amazing. And thank you, Alessia and Luca, of course. I mean, Luca is this one. This guy here is
Not
Luca.
the pizza one. No.
Yeah. It was amazing, of course. And I think we're going to do the same thing next year, maybe improving the sessions, maybe more jokes, more perks. Yeah, you know. 3 social events.
Yes.
Yeah.
You know, we all will remember just 2 of them, but there were 2.
Okay, that picture there, it's like 3 a.m. in the morning, this morning. And every time we go out with Fabio, ends up that way, every time. I don't remember going out with Fabio and not being drunk. So, yeah, so, and then another great decision I made with Patrick. Where is Patrick? There, okay. We decided to organize the PyRun. And I don't know why 7:30 a.m. I don't know.
You did choose.
Yeah, no, we did choose that.
Yes.
Yeah.
The best things that no one asked if there was a shower.
No. And then we thought, why
but
we
no
did...
one knows where it was.
There was a shower by the pool, actually, but we didn't know that, and we said everyone, no, there is no shower here. But you know, I don't know why we didn't choose to do that after the talks, rather than before. I mean, next year. Next year, it's gonna be better. We had Sex Tracks, a workshop on Wednesday, the Humble Data, Django Girls. No, Django Girls actually is today. Sorry. Fiorella, scusa. The Public Speaking, Python Dojo, and Django Notes. So thanks to everyone who took care of organizing all these extra activities. And of course, thanks to Matteo. No, sorry. Yes, Matteo.
The other Matteo. The most important things we want to achieve during PyCon Italia is to have very, very beautiful pics. And it's all in his hands.
Oh, and actually, that one is not alcohol. It's just a, you know, OJ. Yeah. And thanks to Gonzo at Top X for all the services.
Great, great, great work. Thank you. Thank you.
And sponsors. I mean,
thanks. Yeah.
We need money.
Yeah.
That's the truth. So huge thanks to the sponsors. And thanks to the speakers, of course. And now, a huge thanks to you. You, all, everyone.
Yeah, thank you.
Gli piace. And thanks to all the other guys that are not here, because I mean, Saturday.
No applause for them. They should have stayed.
Yeah, no, I mean, now I think most of the people are gone, so but we don't care. I mean, the important people are here now, so.
Thanks to our volunteers. Thanks Santino, Nicole, Pietro, Giuseppe, Santo, Marco, Alessandro, Valeria, Luca, Jacopo, Stefania, Dario, Jess, Stella, Michele, Luna, Edoardo, Giovanni, Federico, Sofia e Yash.
Perché abbracciamo?
Abbiamo anche baciato.
Ma non è finita.
Non è finita.
Non è finita. And of course, thanks to the organizers.
And then we know a lot of people works behind the curtains of an event like this. So we have a lot of teams working. We just want to show you how many of them are and have worked in this event. So the web mobile and app and design. So Marco and Esther and Patrick, of course, our president. We have the schedule and speakers team. We have Ernesto, and Paolo, and Lelio, and Alessia, and Simona, and Raffaella. Sinead and Visa. Again, Esther, and Licia, and Alessia, and Raffaella. The sponsors and media Ambra, Morella, and Sabrina, and me. Social media, Marco and Sabrina. And all this work right here, like me and Ernesto and Glenn. The local community team, great work again. Paolo and Gaetano and Salvo.
Oh. Guess it. So, okay, now, no, huh? No, we don't have dates for next year.
We have dates.
Drew it. So next year, next dates for PyCon Italia 2026 is going to be from 27 to 30 of May.
Yes. And
of course, we're going to be here again.
Here. Okay, it was good. The people is happy. So
yeah, they are happy. So of course we would like to hear something from you. So we have a board outside. If you want to leave a message, feel free to write something. What? Yeah, there's the next slide. Just 1 second. And we're gonna send you a feedback form just to you know, because
in the next days on Tuesday. We'll do it on Tuesday.
Sharp. Yeah, no, because we want to improve something. We want to hear from you because every year is extremely difficult to, you know, go over all the points that you suggest us. So every year we're gonna try to put more commitment on the activities. So this year, we decided to have a short feedback form rather than the one that we sent last year. No?
Yes.
We screw up again. Okay, we fucked up.
Yes, we already have a few ideas to improve things next year, and we have worked also on creating a new feedback form, smaller and simple, and just the things we need to hear from you. And so it's very important for us to understand your thoughts, your opinions, your just dreams about how you want this event to become in the future. So please do it whenever we will send it.
Soon? ASAP. Okay. Okay, thank you guys. See you next year.
Yes. just want to take a pic with all the yellow shirts, and then I will give you a message.
Dai. Luca. Sophie. Glenn. Secondo me dovrebbe venire anche Harlo, però Harlo... Yash.
Vi odio.
Ok. Thank you. Potete tornare un attimo a sedere? Marco! Ok. Posso chiedervi di tornare a sedervi un attimo? Devo dire una cosa. Sì. Vai via anche te? Vai via anche te, vai via anche te, come vuoi. No, basta che mi dai la via. Aspetta, resta qua, resta qua. Ok, I will try to say this in English. This is a message for all the people who cares of Python Italia. So maybe someone of you won't be interested, would like to go, and it will be hard. Okay. I have never written a line of code. I'm not a developer. And apart from wasting a bit of time over Ernesto, and I never programmed. There was a time when this made me feel inadequate when I was at PyCon. But it was a very brief period, because then, in reality, all I had to do was look around me. I have not had an easy life, and learning to recognize the good things I have done and do is often difficult for me. But thanks to the wonderful people around me, I am learning to do it. Speaking around wonderful people, many of the people who are part of PyCon Italia are among the most beautiful people I have had the honor of knowing in my life. I believe it's precisely for this reason that doing things for this group, for these people, for these friends, for you, has never been a burden, but only a motivation. No matter how exhausting or stressful, I would never change this experience for anything in the world. And I am only grateful to life for giving me the opportunity to intertwine the thread of my destiny with that all of you. That is why last year, when we decided to leave our old home, to give PyCon Italia the chance to grow and evolve, I felt the need to create something that would remind us of the journey we had made together to that point. Like the journey, this gift is not perfect. And just like that thread, the testimony is only a passage between what brought us here and what will take us tomorrow. In a day, in a year, or in a lifetime. I am pleased to invite all those who care about the association and the people who are its beating heart to be with us for this moment. It will not be as brief as we had imagined, because it's very, very difficult to condense all the emotions that are there. But this is the documentary we made during the last edition of PyCon in Florence. It will take about an hour. Feel free to go or stay. We will love you anyway.
Scusate, noi non capiamo molto di tecnologia.
Black Magic.
È rotto.
Bloccato, non va. No, ma il bloccato non...
Ha rotto tutto.
Non va.
Possiamo provare a attaccarlo direttamente nell'impianto. Ma puoi? Aspetta,
Io faccio un po'.
Mi piace mandare l'HDMI.
It works.
Mi piace l'HDMI come fonte per Blackmagic. No, mandano un impianto, poi non si ancora.
Sì, ma se io lo metto non si blocca.